You've probably heard people say AI is taking over, but here is the real truth. AI is only as powerful as the data behind it. And here are 4 reasons why I made that statement. First, data skills are the foundation of AI. AI, machine learning, and automation all depend on clean, structured, well-managed data. If the data is wrong, everything built on top of it fails. That's why data professionals are still in high demand. Second, businesses need humans who understand data. Even with AI tools, companies will still need people who can build databases, write queries, interpret results, fix issues AI can't recognize, and more. AI can generate insights, but humans decide what actually matters. Third, data roles are becoming more important, not less. In 2025, companies are dealing with bigger data sets, more complex system, stricter data policy rules, faster decision-making cycles. This creates even more opportunities for data analysis, DBAs, data engineers, and SQL professionals. And the 4th reason is AI needs oversight. AI can automate tasks, but it cannot replace human judgment, especially when it comes to accuracy, ethics, privacy, or business context. Hi everyone, my name is Nikisha Pope, and I'm excited to guide you on your learning journey. I've been working in the tech industry for over 6 years, specializing in SQL, databases, data management, and backend technologies. I currently teach SQL and database administration, and I also have an online presence teaching C, C++, and Linux, covering everything from foundational programming skills to practical system-level concepts. Over the years, I have developed a true passion for working with data, manipulating data, and helping others understand how information flows through modern systems. Whether it's writing efficient queries, designing clean database structures, or troubleshooting complex issues, I love tuning technical concepts into something easy to understand. This course will take you from SQL basics to advanced real-world skills you can apply immediately. You will learn how to write queries, design and normalize databases, use joins and Windows functions, optimize performance, and work with real datasets. By the end, you will be able to build, query, and tune relational databases and confidently explore data for analytic or engineering tasks. So, if you want to build a strong foundation in SQL, understand data from the inside out, upskill for modern tech world, stay relevant no matter how AI evolves, then you're in the right place. This course will be constantly updated as new technology comes in. So once Oracle have a new update, I'm going to update this course as time goes by. So let's get ready to master data in the real world. For this part of the tutorial, we're going to download a special tool called Oracle SQL Developer. It is a free IDE provided by Oracle Corporation for working with Oracle databases. It's designed to simplify database development and management tasks for developers, database administrators, and data analysis. We're going to use SQL Developer to learn how to query a database and also to learn SQL commands. To download Oracle SQL Developer, we're going to go over to Google, and in the search bar, we're going to type in SQL Developer. And the first link that shows up, SQL Developer Download, we're going to click on that link, and it's going to take us to the Oracle page. It's going to ask you to accept the cookie, so I'm going to click on Accept All. You're going to choose your operating system to download. So I'm on Windows, so I'm going to choose the Windows 64-bit. I'm going to click on Download. Once download complete, we are going to open the file location. We're going to right click to extract the file, and we're going to click on extract all. We're going to leave the file that we're about to extract in the download folder, and then I'm going to click on extract. Now that the file is extracted, we're going to double click on the SQL folder, and you see here we have SQL Developer. We're going to double click on SQL Developer. We're going to click on No, and it's going to open up SQL Developer for us. So this is what the database is going to look like when we open it at first. Now that we have the application, we need to connect to a server in order for us to get access to the database. Let's go back into Google and download Oracle 11G. We're going to head back to Google, and in the search bar, we're going to search for Oracle 11G Express Edition download. We are going to click on the second link that says XE Prior Release Archive, and it's going to take us to this page. We're going to choose Windows 64-bit because this is the machine I'm currently on. So I'm going to click on download, review and accept the terms, and download. It's going to ask me to log in. I'm going to put in my username and password. And I'm going to sign in. You must create an account with Oracle in order for you to download any of the software. We are going to open the file location. Also, right click, extract the file. We're going to keep it in the same download folder and click on extract. Let us double click on disk 1. We're going to click on setup. For the installation, we're going to follow the guide and click on next. We're going to accept the terms, click on next. It's going to ask to choose a destination location. We're going to leave it in the C drive, and we're going to click on next. It's going to ask us to enter a password. So I'm going to create a password. It's going to ask us to confirm a password. I'm going to also enter a password. Now for this setup, you must remember the password. You need the password in order for you to get access to the Oracle database. So I'm going to enter my password and click on next and install. And we're going to click on finish. Now if we go into the start menu, we go into all. If we scroll down, you're going to see Oracle Database 11G Express Edition. We're going to click on the down arrow, and we're going to see all of the database software that comes with Oracle Database 11G Express Edition. Now do remember that Oracle 11G Express Edition is an outdated version. Once you get familiar with 11G Express Edition, you can go ahead and update your database to the most recent edition. So for now, we're going to work with 11G. In order for us to connect to Oracle database, we need to open up the SQL Start Plus command line. That package comes when you downloaded Oracle database. So let's go to our apps, and then we're going to head over to all. We're going to scroll down to Oracle Database 11 Express Edition, and you would see Run SQL Command Line. We're going to click on this option. So this is the command line, SQL Star Plus. In the command line where it says SQL, we're going to type in conn, C-O-N-N, lowercase, enter. It's going to ask for username. The username is sys as sys DBA. We're going to hit on enter, and you're going to enter the password that you created when you were installing 11G. So I'll put in my password and hit enter. Once it's connected, we're going to go back and Open back up SQL Developer. Once Oracle Developer opened up, we can see here we have the XE database. So it detected our database this time. Now we have to create a connection. So to create a connection to use the database, we're going to click on the green plus icon. This is where we're going to put in all of our information. So the name will be sysdba. The username will be sys as sysdba. Then you're going to enter the password that you used when you were installing the database. So I'm going to enter my password. We're going to leave connection as basic. We're going to leave the host name as localhost. The port will be 1521 and the SID will be XE. Now, before we click on save and connect, let's test to see if we get a connection. Right where it says status, it should show if the database has connected successfully or if it failed. So let's click on test. And it said success. Now, if I change the password to the database, for example, if I remove one digit from the password and I click on test, it will say failure because I did not put in the correct password. So let me go back and put in the proper password and click test, and it says success. So now we can go ahead and hit on save and then connect. It's going to ask for the password again. I'm going to enter my password and I'm going to click on OK. If you want to rename the database connection, you can right click, go down to rename connection. It's going to ask you if you want to proceed with this step. Click on yes. And then you're going to rename the database connection to whatever name you want. So for me, I'm going to rename my connection as NikiDB and click apply. Now we're going to create another connection where we can load the HR database into that connection. So we're going to click on the green plus button. This time we're going to name this database HR. The username will also be sys as sysdba. I'm going to enter my password. I'm going to leave it as basic. I'm going to leave the host name as localhost, port 1521, SID will be XE. I'm going to click on test. The status is success. So I'm going to click on save and connect. I'm going to enter my password again and hit OK. The font size is a little bit small. So to increase the font size, you go to Tools, Preferences, go down to Code Editor, then Fonts. Right now we're at 12 font size, so let's increase it to at least 16 and then press OK. Now inside of the text box, I'm going to type in alter user HR account unlock. So this will unlock the HR user account for us. So I'm going to click on run. If I go down to the output, it says user HR altered. We're going to write another statement, alter user HR identified by DBA. We're going to highlight the query, click on run, altered user. For this part of the course, I'm going to show you how to use the online database from Oracle. You don't have to download Oracle Developer in order for you to learn SQL. So inside of Google, you can type in Oracle Online Database. Then you scroll down until you see Oracle Live SQL. You're going to click on that link. And then when you get to this page, you will have two options. You have Start Coding, and then you have View Scripts and Tutorials. We're going to click on Start Coding. And when you get to this page, you're going to see little pop-ups showing you how to navigate the online database. So we have Object Browser. If I click on Next, we'll have Run Statement. If I click on Next, it will show me where my query result will be. If I go ahead and click on Next, it will show me the data grid. If I click on Next, it will show me the SQL history. it will also show me the format of SQL. So you can go ahead and play around with the navigation until you get familiar with the online system. So on the left, we're going to have a list of tables. But before we start writing queries, I always recommend to log in or create your login credential or sign up. So once I finish signing up or logging in, then I'm going to get to this screen. This is my schema. On the schema, I have a list of different databases. So I have the academic database, analytic views, customer orders, human resource, order entry, Olympics data, and so forth. But for this course, we're going to focus on HR human resource database. Under the HR database, you can see that I have a list of tables. For the tables, I have countries, departments, employees, jobs, job history, locations, and regions. So these are the tables we're going to work with. Now, inside of the worksheet, that's where you're going to write your query. So I'm going to start off with select star from employees. Now, if I run this query, it will give me an error. And the reason for the error is I always have to write hr.employees if I'm using the online database. So I'm going to go ahead and run the query. And here you can see that we did get an error telling us that we need to use the database name. So I'm going to go back into the query and type hr dot. And I'm going to go ahead and run the query again. And this time we get back the proper results. So just remember, when you are using the online portal, is hr dot and the name of the table. For this part of the course, we are going to use the HR schema that is available in the Oracle database. In the HR schema, we have 7 tables: job history, jobs, departments, employees, locations, countries, and regions. Inside of each table, we can see the column names. As I said previously, if you do not have SQL Developer application downloaded on your computer, you can access the online database on Oracle. And inside of the online database, we have the exact same tables in the HR database: countries, departments, employees, jobs, job history, locations, and regions. What is SQL? SQL stands for Structured Query Language. It is the standard programming language used to interact with relational databases. It lets you store, retrieve, update, delete, and manage data efficiently. You may be asking, what is a relational database? A relational database is a type of database that stores information in tables made of rows and columns, and these tables are related to each other through primary keys and foreign keys. In this course, we are going to go over all of the SQL statements, including the DML statement, which stands for Data Manipulation Language. And on the DML, we have commands like select, insert, update, delete, and merge. Then we're going to take a look at DDL statements, and DDL stands for Data Definition Language. And on the DDL, we have statements like create, alter, drop, rename, truncate. We're going to also take a look at DCL, which stands for Data Control Language. And on the DCL, we have the grant and revoke command. And the last one is TCL. TCL stands for Transaction Control. And on the TCL, we have commands like commit, rollback, and save point. We're also going to take a look at a lot of more statements in SQL and other procedures, which include indexing, CTEs, views, ETLs, normalizations, and a lot more. So let's go ahead and begin the course. Database objects are components within a database that stores, manages, and organizes data. They come in various types depending on the database system and are used to structure and manipulate information efficiently. Here are some of the main objects in a database. We have tables that store data in rows and columns. It is the fundamental unit for organizing data in a database. We have views, which are virtual tables that display data from one or more tables based on a query. We have indexes, which optimize the speed of data retrieval by creating pointers to specific rows in tables. We have triggers, which automate action activated by specific events in the database. We have sequence, which generates unique numerical values, often used for primary keys. We have synonyms, which are alternate names for database objects to simplify access. And we also have stored procedures, which are predefined SQL codes that automates tasks or queries. Stored procedures are commonly used in the programming side of SQL, known as PL SQL. For this part of the course, we are going to use the HR schema that is available in the Oracle database. In the HR schema, we have 7 tables: job history, jobs, departments, employees, locations, countries, and regions. Inside of each tables, we can see the column names. As I said previously, if you do not have SQL Developer application downloaded on your computer, you can access the online database on Oracle. And inside of the online database, we have the exact same tables in the HR database: countries, departments, employees, jobs, job history, locations, and regions. The first command we're going to look at is the describe command. The describe command is used to show the structure of a database table. This command provides information about the columns of the table, including their names, data types, and any constraints that might be applied to them. For instance, we have the employees table in our database. If I want to see the structure of that table, I will use the command describe employees. I'm going to press the green play button to see the results. Name is the name of the columns in the table. Not null indicates that the column must contain data. Type display the data type of the column. A SQL select statement is a fundamental part of the structured query language. It is used to retrieve data from a database. For instance, I have the table employees inside of my database. If I click on the plus button, you would see a list of columns that is inside of the employees table. I have the column first underscore name and last underscore name. If I want to retrieve first name and last name of each employee, the query would look like this: select first underscore name, comma, last underscore name from employees. The select clause specifies the columns you want to retrieve. First underscore name and last underscore name are the columns you want to fetch the data from. The from clause specifies the table from which to retrieve the data from. Employees is the name of the table containing the data. If I hover over the green play button, it will say run statement. I'm going to click on that button and we will get the results from the employees table. This is called querying the database. If we look at the query, first name and last name is in lowercase. If we go under the employees table, all the columns inside of the table is in uppercase. SQL statements are not case sensitive. The clause can also be lowercase as well. So if I delete the select statement and I rewrite it in lowercase and I run the query again, I would still get back the same result. When writing the select statement, each column must be separated using a comma. If I remove the comma from the statement and run it, I will not get back the result that I want to get. Also, semicolons are required when you execute multiple SQL statements. However, if I'm just writing a simple select statement, the semicolon is not necessary. So if I remove the semicolon and run the statement again, I will still get back the same results. You can display all columns in a table by listing the column names after the select statement. However, in SQL, there is a shorter way to display every column in the table by using the asterisk. So I can say select asterisk from employees. I'm going to run the query, and this will display the data of every column inside of the employees table. The distinct keyword in SQL is used to return only unique values from a column or a combination of columns, removing any duplicate values in a result set. This is especially useful when you need to see a list of unique entries. For example, we have a department ID column in the employees table. Now, if I say select department ID from employees and I run this statement, I will get a list of duplicate values. If you want to eliminate this type of results, you can use the distinct keyword. I can say select distinct and the name of the column. Now, when I run this query again, I will only get back the values without any duplicates. The order by clause is used to sort results in ascending or descending order. By default, SQL sorts the data in ascending order. However, you can override that by using specific keywords. For example, I have this query, select hire date, first name, last name from the employees table. So if I go ahead and I run this query, this is the results I will get back unsorted. If I want to sort the data by hire date, I can use the order by keyword. So I can say order by and the column name that I want to sort the data by. In this case, I want to sort the data by hire date. And I'm going to go ahead and run this query. Now you can see that the results have been sorted in ascending order. Now, if I want to sort it in descending order, so from highest to lowest, then I can use the keyword this, and this will override the default of sorting in ascending order. So I will go ahead and run the query. And if we look at the result, it has been sorted from highest to lowest. Now, I can also sort the data by the position of the column. For example, hire date is the first column that I have in the select statement. So I can say ordered by 1. 1 represent the position of the column in the select statement. So if I go ahead and I run the query, I will still get back the same results. Now let's sort the result by last name. So instead of saying 1, I can say 3, because in the select statement, last name is in the third position. So I'm going to go ahead and run the query. And if we look here, the last name column has been sorted in descending order. Let's go back and sort the results in ascending order. So I can say ASC SQL sorts results in ascending order. But if you want to use the abbreviation, you can go ahead and use it. So let me run the query again. And if we look here, the result has been sorted in ascending order. Now, if I remove ASC and just use order by 3 and run the query again, we will get back the same result. In SQL, An alias is used to give a table or a column in a table a temporary name. This can be very useful for improving the readability of your queries or renaming columns in a result set. For example, if I want to print the first name of each employee and the job ID for each employee, I also want to rename the first name column to name and renaming the job ID to position. I can do that with the query select first name, and to create an alias, you use the keyword as. After the as keyword, you would give the name of the aliases that you want to rename the column to. After the alias name, you have to give a comma and list the second column. So I also want to display the job ID, and I want to rename the job ID as position. And I want to get this data from the employees table. I'm going to run this statement, and it renamed the first name column to name and the job ID column as position. You can also create an alias by just using a space. So after the column name, you give a space and the name of the alias. I'm going to run this statement again, and I got back the same results. Another way you can create an alias is by putting the alias name in double quotes. Now I'm going to put double quotes around name and double quotes around position. The difference between the double quotes from the as keyword and the space method, whatever you write inside of the double quotes will be the exact same name of the column. By default, alias columns will print in uppercase. If I run this query, the name will be in lowercase and position will also be lowercase as well. Take a look at the results. Usually, developers will use double quotes if they are using any special characters within the aliases. For example, if I want to say employee name with a space, I must enclose it in double quotes. Now, if I run this statement, I would get employee name. If I remove the double quotes around employee name, I will get an error. If I hover over it, it says syntax error. That's because it's only looking for a single word for aliases if it's not enclosed in double quotes. So if you're using any special characters like space or percentage, it has to be enclosed inside of double quotes. The concatenation operator is used to join two or more strings together. You can also link two columns to create a single output. Different SQL databases uses different concatenation operators. SQL Server, you can use the plus operator to concatenate strings. In MySQL, you can use concat function to concatenate strings. In Postgres and Oracle, you can use the double vertical bars, also known as the pipe. For example, if I want to join the first name and last name column together, the query to do that will be select first name. I'm going to use the two vertical bars and I'm going to specify the other column. And I want to pull that data from the employees table. Now I'm going to run this statement. The first name column and last name column has been concatenated. Now, if you want to put a space between first name and last name, you can do that by using single quotes and an extra pipe. Within the two vertical bar, you're going to use single quote to represent a space. Now, if I run that query again, I will get some space between first name and last name. I can also add an alias to that output by using the as keyword, and I'm going to say employee name. And when I run this query, I just added two columns together and label it employee's name. A literal is a character, a number, or a date that is included in the select list. It is not the name of a column or an alias. It is printed for each row returned. Literal strings are free format text that can be included in a query result and are treated as the same as a column in a select list. For example, if I run the statement select first name, and I also want to select the job ID from the employees table, and I run this query, if I want to add a string to my results, I can do that by using the vertical bar, single quotes, and close it off with another set of vertical bars. These bars also called the pipe, and it's the straight bar right above the backslash. Now inside of the single quotes, I can add any string that I want to add. So I can say job is A and a space. Now when I run this query, it is going to change the output of this result by adding a string to it. So I'm going to run the statement, and here it says Ellen job is a sales rep. Now I can make this a little bit more readable and add a space in the front of job and run this statement again, and I will get back this result. With a literal string, you also have alternative quotes. And alternative quotes are expressions or strings that contains special characters or single quotes. For example, if I use the string employees with an S, this is going to give me an error. To bypass this error, I can use the Q right after the double vertical bars. Then right before your string, you're going to use the open bracket. You're going to close off the open bracket after your string. Now, if I run this statement, I would get back this result. If I want a little bit more readability between the employee's first name and my string, I'm going to go right before my string, give a space, run the query again, and then you have a little bit of readability. You may need to modify the way in which data is displayed by performing some type of calculations or looking at what-if scenarios. SQL allows you to perform arithmetic operations directly within your queries. You can use arithmetic expressions to calculate new values based on the columns in your table. For example, in the employees table, I have a salary column that stores the data for each employee's salary. Let's look at a what-if scenario. If the manager comes to you and say, I want to see what the numbers will look like if we add $100 to each employee's salary. The query to do that will be select first name, last name, and I want to display the data for the salary column as well. I want to pull that data from the employees table. I'm going to run the statement. If you want to add $100 to each employee's salary, you're going to use the arithmetic operator plus and the values that you want to add to each employee's salary. I'm going to run the statement, and we can see from the result that the values has been changed for each employee. I can also subtract $100 from their salary as well, same as multiply, and I can also use division by using the /. If we take a look at the results of each column, the salary divided by 100 is not a new column that is inside of the employee table. It is only for display purposes. Operator precedence in SQL determines the order in which different operators in an expression are evaluated. If an expression contains more than one operator, multiplication and division are evaluated first, then addition and subtraction. For example, if I have this expression, my goal is to add $100 to each employee's salary, and I want to see the result on a yearly basis. If I run this query, 12 times salary is going to be calculated first, then it's going to add $100. If I want to override this expression and have salary times 100 be calculated first, I would have to put salary plus 100 inside of parentheses. So I would go ahead and put a parenthesis around salary plus 100. Now with this expression, salary plus 100 will be calculated first, then it's going to calculate 12 times the results of this expression. When I run this query, take a look at the new result that we got back. So please do keep in mind, multiplication and division occur before addition and subtraction. Operators of the same priority will be evaluated from left to right. For example, if I have this expression, it will calculate 12 plus salary plus 100. In SQL, null values represent unavailable, unassigned, unknown, or inapplicable data. Null is not the same as 0, blank space, or an empty character string. 0 is a number and blank space is a character. In our employees table, we have a column named commission_PCT. This column contains data about each employee who collects a commission. If I run the query, select first name, last name, salary, and commission PCT from the employees table, I will get back these results. In the commission PCT column, only sale managers or sale representative can own a commission. Other employees are not entitled to own a commission, so their values will be null. If you add any arithmetic expression to null values, the result will always be null. For example, if I add salary plus the commission and I run the queries, the data will still be null for the employees who have null values on the commission PCT. Now, if I go down to employees that collects a commission, the salary will be added to their commission. The where clause restricts the rows that are returned from a query. It is used to filter records that meet a certain condition. The where clause contains a condition that must be met, and it is directly followed by the from clause. If the condition is true, the row meeting the condition is returned. For example, in the employees table, we have a column department ID that holds data for each department in the company. If I want to display employees in department 50, the statement will look like this. Select first name, last name. I also want the employee job ID and the department ID as well. And I want to grab this data from the employees table. And for the where clause, you have to specify which department that you want to display the information from. In this example, I want to display every employee in department 50. So I will say department ID equals to 50. Now run this query. It will show me every employee in department 50 together with their job ID. You can also include character strings and date values in your where clause. For example, if I want to pull up information for Adam, I can say where first name equals to, and for character strings, you have to include the characters inside of single quotes. So I will go ahead and put my single quote and specify the name that I want to pull the information for. And in my situation, I want to pull information for Adam. So I will specify Adam inside of single quotes. I'm going to go ahead and run the query, and I get back the information for Adam. Now do remember that in SQL, character values are case sensitive, and so does date values. Date values are format sensitive. If I remove the A, the uppercase A, and put in lowercase a, and I run the query again, I will not get back any results because I changed the case value for the name. Now I can also find hire dates or all the employees who've been hired after a specific year. So in that situation, I can say where hire date, and we do have a hire date column in our table. So where hire date is greater than, I'm going to put the date inside of the single quotes. I want to display all the employees who was hired after February 1st, 2000. So I can say a 00-01-02, and I'm going to run the query, and it brings me back every employee that was hired after February 1st, 2000. The date also have to be format sensitive. For example, if I use this date format and I run the query, I should get back an error complaining about the date format. If you want to see or know the date format on the system, you can use select sysdate from dual, and I'm just going to run this query by itself, and it should give me the proper date format. I can also use this date format, and I will get back the same result. So you have two ways of using the date format in Oracle. So you can either use it this way, or you can say 02, and it will still work. The comparison operators in SQL are used to compare two values and determine whether a condition is true or false. They are essential for filtering data and specifying conditions in the where clause. These operators help you to write precise and effective SQL queries. Here are some of the comparison operators available in SQL. You have the equal to, not equal to, which can represent with three sets of characters: greater than, less than, greater than equal to, less than equal to. And you have the range operators, which are between and. You have the like operator, which searches for a specific pattern. And you have the in operator, which matches any values in a list. For example, in the employees table, I have a salary column. If I want to see any employees who collects a salary over 3,000, the query to do that will be select, and I want to select first name, and I also want to display the salary column as well. And I want to grab that information from the employees table. To filter my results, I can say where salary greater than 3,000. Now, if I run this query, it will bring back for me every employee who collects a salary greater than 3,000. I'm going to order the results so it can be more readable. So I'm going to say order by 2. Order by 2 will order the salary column for me. I'm going to run this query again, and you would see that it prints only the employees who collect a salary over 3,000. Now, if I want to include the employees who collect a salary that is equals to 3,000 and higher, the operator to do that will be greater than equals to. Now, if I run back the query, I will get the employees who collect a salary of 3,000, which is Anthony and Kevin, and greater. I can say less than, and it will bring back all the employees who collect a salary less than 3,000. If I want to include the employees who collect a salary of 3,000 as well, I can use the equal sign, so less than equals to, and I'm going to rerun the query. Now I have Anthony and Kevin in my results. If I want to exclude Anthony and Kevin, I can say not equal to, which can be represented by this set of operators or this sets of characters. And I'm going to rerun the query. Now, if I scroll down, Anthony and Kevin is not there in the list because they are collecting a salary of $3,000. I can also represent not equal to with exclamation equals to. So by adding the exclamation in front of the equal to sign will reverse the operation. So if I run the query again and I scroll down, Anthony and Kevin is not in the list. And the last set to represent not equal to will be Shift 6, which will give me that little anchor sign, and equals to sign. And I'm going to rerun the query and scroll down, and I still get back the same results with Anthony and Kevin excluded. These are the operators you can use to filter out records in an SQL query. The between operator is used to display results in a specific range. It includes the value at the start and end of the range. It is often used with numeric, date, or even text values. For example, if I want to display all of the employees whose salary is between $1,000 and $3,000, the query to do that will be select first name, last name, salary from employees, where salary between $1,000 and $3,000. And I'm going to order it by 2. So 2 will represent the second column in the select statement. So I'm going to run this query, and the result will be all the employees whose salary is between $1,000 and $3,000. When using the between operator, the range that you specify contains a lower limit and an upper limit. The lower limit is 1,000 and the upper limit is 3,000. The lower limit must come first. So if I reverse the order and I put 3,000 here and I put 1,000 here and I run the query, I will not get back any results. If I want to display the employees who were hired between a specific date, I can do that with the between operator. In my select statement, I'm also going to include the hire date, and we do have a hire date column in our table, and instead of saying salary, I'm going to say hire date, and I want to display the employees whose hire date is between 2000 and 2009. The date has to go between the single quote. So I'm going to say 2000, January 1st, day 1, and 09, 12, 31st. So this is going to be January 1st, 2000 to December 31st, 2009. And I want to order this column by 3, which will be the hire date. And I'm going to run this query, and I got back all the employees whose hire date was between 2000 and 2009. If you want to know the date format for your system, you use select sysdate from dual. And if I run this query, it will give me the format for the date on my system. The in operator, also called the membership condition, is used to test for values in a list. I have a column in my table called Department ID. If I want to print all of the employees in Department 50 and 100, the query to do that will be select first name. I want to display the department as well, so I'm going to say Department ID. And I'm grabbing that information from the employees table. And to use the in operator, I'm going to say where department ID in. With the in operator, you must include the values inside of brackets. So I'm going to use the open and closing brackets, and inside of the brackets I'm going to say 50 and 100. So I want to display the first name and the department ID of all the employees that works in department 50 and 100. And I'm going to run the query, and this will be the results. If I scroll down, it will only show me the employees in department 50 and department 100. The like operator in SQL is used to perform pattern matching or wildcard searches in a query. Such condition can contain either literal characters or numbers. There are a couple symbols in SQL that can help you limit your results when searching for a specific pattern. For example, in my table, I have a job ID column. If I want to find the employees who work in the IT department, I can say select, and I want to select the first name, job ID from employees, where job ID like. Your search pattern has to be inside of single quotes. Now, if I know the exact spelling of the job ID, I can just write it out. So for example, if I want to pull information from the IT department, I can say IT underscore prog. Now, if I run this, I would get back everyone who works in the department. Now, what if I do not know the proper spelling of the department? It can be IT department, IT programmers, IT programming. If I don't know the exact spelling, that's when the wildcard will help me limit my results. So if I know that the beginning of the department is IT, then I can go ahead and use the percentage symbol. The percentage represents any sequence of 0 or more characters. So once you put the percentage in your search, it means that anything after the keyword IT. So look for any space, any letters, any characters after IT. Now, if I run this query, I should get back the exact same results. If I want to search for people in the sales department, so I can say SA and give me anything after the A, one or more characters after the A. And I run this query, it will give me everyone who worked in the sales department. You can also move the characters around. So I can say rep, but in front of the rep keyword, I can put the percentage sign. So it's going to look for any characters before the keyword rep. Now, if I run this, I will get back all the employees who are rep. You also have the underscore, which represent a single character. So I can say, give me back employees whose second letter starts with an A. So I can say, give me a single character in the beginning, and the second character has to be an A. And you can have anything after the A. Now, if I run this query, if we look here, all of these employees' second character in their name is an A. You can also do the same for dates or numbers. For example, if I want to find employees whose hire date was in 2003, I can say job ID, hire date, and instead of saying first name, I will say hire date. And to search for dates has to be inside of single quotes as well. So if I want all the employees who start in 2003, I would say 03, which is the year. So in Oracle, the date pattern is year, month, day. So the year comes first, and I'm going to put the percentage sign, which means that anything starts with 03, and it doesn't matter the day or the month. So I'm going to run this query, and it prints everyone who is in the company or their hire date was in 2003. I can also test for nulls in my database by using the isNull operator. For example, if I want to find all of the employees who do not collect a commission, the query to do that will be select first name, salary, commission, PCT from employees where commission PCT is null. So this query will bring back all the employees who do not collect a commission. Now, if I run this query, the result will display only the employees who the commission column is null. There are three logical operators available in SQL. You have AND, OR, and NOT operator. For example, if I want to display the employee, job ID, and salary who has a salary greater than 5,000 and work in department 20, the query to do that will be select last name, job ID, salary from employees where salary greater than 5,000 and department ID equals to 20. In this query, the employee salary must be greater than 5,000 and department ID has to be equal to 20. Both conditions must be true. If any of those conditions is false, I will not get back the result I'm expecting. So I'm going to run this query and I got back Hartstein and Faye. Now, if I change this and I put a department that does not exist. So for example, I can say department 1000. When I run this query, I will not get back any result because there is no department ID in the database that is 1000. I'm going to change it back to department 20, run the query again, and this is my result. The OR operator requires either condition to be true. So if I change the AND to OR, the recommendation now will be different. So either the employees has to have a salary over 5,000 or they have to be working in department 20. Now, if I run this query, I will get back a lot of employees who makes a salary over 5,000, but not necessarily in department 20. Now, if I add the department ID to this query and run the query again, you would see that a lot of the employees do not work in department 20. The NOT operator is used to invert the result of a condition. When used in a where clause, it will return the opposite of the condition specified. If I want to return the first name, salary, and job ID for every employee except the employees whose job ID is manager, the query will be select first name, salary, job ID from employees where job ID not like, I'm going to use the percentage, which will give me any characters before, and I'm also going to use the percentage again at the end to give me any characters after the man keyword. Now if I run this query, I will get back every employee except the ones whose job ID is a manager. If I want to display every employee except the ones in a specific department, I can do that as well with the NOT operator. So I can display their department ID, and in my where clause, I'm going to remove job ID and use department ID. And I'm going to say department ID not in, and I'm going to use the open brackets. And I do not want any employees who department is in 50 and 90. Now I'm going to run this query and it will bring back every employee except the ones who's in department 50 and department 90. Now, if I run this query by itself, there are some employees who are in department 90 and in department 50. You can also use the not operator for null expressions as well. So if I add the commission PCT column and I said I want commission PCT is not null and run the query, it will give me back every employee who collects a commission. Now, if I go here and I run this query by itself without the where clause, we can see that some of the employees do not collect a commission. I can also use the not operator with the between operator. So I can say where salary not between 1,000 and 2,400. Now, if I run this query, I will get back all of the employees whose salary is not between 1,000 and 2,400. Substitution variables, also known as bind variables or placeholders, allow you to pass values dynamically at runtime, making your queries more flexible and secure. For example, if I want to print all the employees' information from a specific department, however, I do not want to hard-code the department ID, I want the person who is interacting with the program to input the department ID themselves. The query to do that will be select star from employees where department ID equals to, inside of single quotes, I'll use the ampersand. I will give my variable a name. So I'm going to call my variable department, and I will close it off with the single quote. Now the ampersand represent substitution variable. Department is just the name of the variable that I chose. Now, if I run this query, it's going to ask me to enter the department ID. So I'm going to say, I want to see everyone's information in department 100. If I run this, it will print everyone's information in department 100. If I rerun it, and this time I'm going to say, give me everyone in department 50, and it will print all the information of the employees in department 50. You can also add conditions in your where clause when using the substitution variable. For example, I'm going to delete this line and I'm going to say where ampersand, and I'm going to give this variable name condition, and I want to order by, and I'm going to give another ampersand and column. This query will allow the user to input their own condition and also input the column that they want to order the query by. Now I'm going to run this query and it's going to ask me to enter a value for condition. Now for this condition, I want salary greater than 10,000, and I'm going to hit OK. And I want to sort the column by salary, and I'm going to hit OK. Now if I go to the salary column, the column is sorted in ascending order, or from lowest to highest. The define and undefined commands allows you to create and delete user variables respectively. These commands are very useful when you want to define variables that can be used multiple times within a session. To create a substitution variable using the define command, you use the keyword define and the name of your variable. So the name of my variable emp underscore no, which means employee number, and I'm going to assign a value to that variable. So the value I'm going to assign is 200. Now in the select statement, I'm going to say select. I want the employee ID. I also want first name. I also want last name, the job ID, and salary. And I'm going to grab this information from the employees table. And in the condition, I'm going to say where employee ID is equal to ampersand EMP underscore NO. So in the where clause, it's going to substitute EMP underscore NO with 200. Now I'm going to run this query and it gives me back the information for employee who has the ID 200. So in this case, Jennifer Walland is our employee. Now, if I want to undefine or remove that variable from my program, all I have to do is write undefine and the name of the variable. Now, I'm going to run it and it says query run. The verify command is used to toggle the display of old and new values when a substitution variable is used in the query. It helps you to see what the actual query will look like once the variables are replaced with their respective values. This can be useful for debugging and verifying your queries. To enable or disable the verify command, you can use the syntax set verify on, and I'm going to copy everything, run the query. If we look at the result area, you will see all the values that has been run previously for each variables. For this example, I'm going to change the condition to salary greater than 10,000. I'm going to hit OK, and I want to sort the column by department ID, and I'm going to hit OK, and I got back the results and it is sorted by department ID. Now, if I run this query again, it will show me the last condition that I applied to the your condition variable and the last ordered by I applied to column name. Now, if I scroll up here, you will see all of the condition that was applied to the variable. So on top it says old, 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 and in the bottom was the latest one, new. Now, if I want to set a verify off, all I have to say is set verify off. SQL functions are powerful tools used to manipulate and process data within a database. There are two main types of functions in SQL: single row function and multi-row, known as group functions. Single row functions operate on individual rows and return one result per row. Some of the single row functions are strings or character, date, number, and conversion function. Multi-row functions, on the other hand, operate on a set of rows and return a single result. These functions are particularly useful for summarizing data. Some of the multi-row functions are count, sum, av, max, and mean. First, we're going to take a look at single row functions. These are a list of single row functions available in SQL. Let's take a look at some of these functions individually. First, we're going to take a look at the concat function. The concat function allows you to join values together or join two columns together to get a single result. For example, if I want to print first name, last name, however, I want first name and last name to be printed in one column together with the employee job ID, the query to do that will be select, and I'm going to use the concat function, and inside of apprentices, I'm going to say first name, and I also want last name, and I also want to print the employee's job ID, and I'm getting that information from the employees table. Now, if I go ahead and run the query, you can see that the first name and last name column has been joined together. The next function I'm going to look at is the substr function, and that function allows you to extract a string of determined length. For example, if I want to display only the first two characters in the employee's job ID column, I can do that by saying sub-str. Inside of apprentices, I'm going to say job ID, and I have to specify where do I want to start and where do I want to stop. So in this situation, I want to start at 1. So start from the first character, go up to the second character, and I'm going to run the query. And here, instead of getting AC manager, I get AC. So if I go back here and add job ID and run the query again, you would see it extracted the abbreviation. The length character will show the length of a string as a numeric value. For example, if I want to display how many characters or how many numbers in each employee ID, I can say length, and I want to find the length of the employee ID. Now, if I run the query, it will tell me how many numeric value or how many numbers in the employee ID. Now, if I come here and display the employee ID and run the query, you would see that each employee ID have 3 numeric value. The next function we're going to look at is the instr function. And that function allows you to find the numeric position of a named character. I'm going to remove some of this query. I'm also going to remove sub-str as well. And I want to display job ID. So I'm going to use the instr function together with the job ID. And I want to find every employee who has man in their title. Now I'm going to run the query and it will tell me where I can find the keyword man. So if I scroll down, I can find it here, MK man. Scroll down again, we have PU man, SA man. So the instr function just let me know where exactly I can find the numeric position of man, which means manager in the database. The lpad function returns an expression left padded to the length of the end character. So for example, if I display salary, I want to left pad the salary column with asterisks. I can say lpad, and inside of apprentices, I'm going to specify the column that I want. So I want the salary column. And I have to tell lpad how many characters in total do I want. So in total, I want 8 characters, or I can say 10 characters. And I want to left pad with an asterisk. I'm going to run the query. It's going to be 10 characters altogether. It will look for how many characters available, and then it will pad it with our asterisk to make it 10 character. Now, this is useful for readability or formatting output to maintain constant length. It doesn't have to be asterisk. I can also put $sign in front of it. And if I run it, it will pad it with $sign in the beginning for me. So I'm going to go back and put back the asterisk. Now I can also do that for right pad as well. All I have to do is remove the L and use the R. And if I run it again, it will pad it with asterisk on the right side. The last one I want to look at is replace function. And the replace function will let you replace a string with another string or replace character with another character. I'm going to use the replace function, and I'm going to tell the replace function to look for the job ID column. And inside of the job ID column, look for the keyword IT. And I want you to replace IT with tech. Now, if I run this query, and we scroll down, let's look for anything that says IT. You see here at number 14, I have IT probe, and it replaces IT for me with the keyword tech. On the character functions, we have single row character function that accept character data as input and can return both character and numeric values. Character functions can be divided into two parts: case conversion functions and character manipulation functions. Under case conversion functions, we have lower, upper, and init cap. The lower function will convert alpha character values to lowercase. The uppercase function will convert alpha character values to uppercase, while the init cap function will convert only the first letter to uppercase of each word. For example, I have this query on my screen. Now, if I run this query, in the first name column, only the first letter is in uppercase, same as with the last name column. Now, if I want to make the first name column all uppercase and the last name column all lowercase, I just have to use the upper function for first name, and it has to go inside of parentheses, and I want the last name column to be all lowercase, so I will just use the lower function and also enclose it in parentheses. Now, if I run the query, you would see that the first name column has been changed to uppercase and the last name column has been changed to lowercase. Now, when it comes to the init cap function, I can say init cap. For example, if I want to say hello world and I'm going to run the query, you can see that it converts only the first letter of each word. I'm going to delete the words inside of the init cap function and I'm going to make it all uppercase and run the query, and you can see that we still got back the same results. Number functions accept numeric input and return numeric values. These are the three number functions available in SQL. You have round, that will round the value to nth decimal place. Trunc will truncate the value to nth decimal place, and mod will return the remainder. For example, if I add to each employee's salary $43 and let's say 687 cents, I'm going to run this query, and you can see in the result we get back 3 digits after the decimal place. Now I can go ahead and round this off so it can be 1 digit or 2 digits after the decimal place. So I can say round, and I have to tell the round function how much do I want to round it off by. So if I want to round it off to 2 decimal place, I would have to specify 2 inside of the round function. Now I'm going to run the query, and you can see that it has rounded the digit down to 2 characters after the decimal place. You can use the trunc function if you want to truncate the values down to a specific position. So instead of saying round, I can use the trunc function, and I have to tell trunc how much I want to truncate this value down to. So if I use 2 and run the query, you see here it did not round it off for us, it just truncate the value down to 2 decimal place. Now I can also say trunc it down to 1 character after the decimal, and it will do that. The last one is the mod function, and the mod function will just give us the remainder. For example, I can come here and say mod, and instead of saying salary plus 43.678, I'm going to say 1000. So after it divides the salary, it's going to give us the remainder from that operation. So I'm going to run the query, and if we look here, it has modified the salary column for us. I'm going to go back in the select statement and print the salary column so we can see the difference. Now I'm going to run the query, and if we look here, salary divided by 1000, for Harold it will give us no remainder. Now for Austin, when it divided by 1000, we got 4 with a remainder of 800. So the mod function only going to give us the remainder of the division. Group functions also known as aggregate functions, are used to perform operations on multiple rows of a table and return a single value. These functions are very useful in summarizing data. Here are some of the most commonly used group functions in SQL. If I want to get the sum of the salary column, I can use the syntax select, and I'm going to use the function sum and the name of the column that I want to sum, and I'm going to get this information from the employees table. Now, if I run this query, it's going to give me a sum of the salary column. If I want to find the average salary, I can use the syntax AVG, which stands for AV. I'm going to run the query, and it's going to give me the average salary for the employees table. If I want to see the max salary, I can use the max function, and when I run the query, it will give me the max salary. If I want to see the mean salary, I can use the mean function and run the query. It will give me the mean salary. If I want a count of all the employees in the employee table, I can use the count function, and inside of the parentheses, I'm going to use the asterisk, which represents all. And I'm going to run the query, and I have 107 employees. I can also count the department ID, and when I run the query, it will give me a count of the department ID. Now, with the count function, I can also use distinct. In the database, there is not 106 department. It's actually lower. With this syntax, the value for department ID has been duplicated. Now, if you do not want any duplicated values, you can use the distinct keyword, and that will eliminate duplicates. So if I run the query, you can see here we get a different value, which is 11 departments in the employees table. Grouping rows in SQL involves using the group by clause. The group by clause allows you to arrange rows that shares the same values in a specified column. After grouping the rows, you can perform aggregate functions such as sum, av, min, max, and count. For example, I have this query on my screen, and if I run the query, I will get back the average salary from the employees table. Now, what happens if I want to get back the average salary for each department? So I can say department ID. Now, if I run this query, I will get back an error. Now, if we take a look at the error, it will say not a single group function. If I want to get rid of this error, I would have to use the group by clause. So I can say group by, and you must put the department ID inside of the group by clause in order to get rid of this error. So I'm going to say group by department ID. Now, if I run the query again, I will get back the result that I wanted to get. The department ID or the column that you have in the group by clause does not necessarily have to be in the select statement. So if I remove department ID and I run the query, I will get back the result, but just that the department ID will not be displayed. So I'm going to rerun the query. And if we look at it, we will only get back the average salary for each department. Now, there are some rules when it comes to using the group by clause. Every column in the select statement that is not an aggregate function must be included in the group by clause. For example, if I put back department ID and add job ID, and if I run this query, this will bring back an error. I need to put job ID in my group by clause. So if I come here and add job ID and run the query, it will work. So just remember, whenever you're using the group by clause, any columns that is not aggregated, so which is department ID and job ID, it must be in the group by statement. Another thing when it comes to group by clause is grouping non-unique identifiers. For example, if I go to the employees table and the column employee ID will not be a good selection to put in the select statement because employee ID is unique. Sometimes even phone numbers can be unique as well. So you have to be very mindful of which column you're putting in the select statement because that can bring back unwanted results. Another error you can come across with the group by clause is using aggregated functions in the group by clause. So for example, if I copy av salary and I put it in the group by clause and run the query, I will get back an error. Average salary is aggregated, so you do not have to put it in the group by clause because this is already a grouping function. You can use the where clause or the having clause to restrict grouped results. However, there are some differences when using both. The where clause will filter rows before grouping, and the having clause will filter rows after grouping or after aggregation. For example, I have this query. If I want department greater than 30, I can do that by saying where department ID is greater than 30. Now, if we look at the where clause, it's before the group by statement. Now, if I run this query, I will get back everyone in the department greater than 30. Now I can come here and say order by 1. And when I order by 1, it's going to order the department ID. Now I'm going to run the query again. And if we look at the results, it displays every employee who works in department that is greater than 30. The where clause cannot be used to restrict groups. For example, in the select statement, I have av salary. Now, I cannot take av salary and put it in the where clause to say have average salary greater than 13,000. Now, if I run the statement, I will get back an error. And it says here, group functions is not allowed here. The having clause is applied to aggregated data. For example, if I want to display the average salary greater than 5,000, I can come to the bottom of the group by clause and say having av salary greater than 5,000. Now, if I run this query, the results will display how I want it to. So if I remove the department, say where department greater than 30, and instead put av salary greater than 5,000, and I'm going to comment the having clause. Now, if I run this query, it will tell me group function is not allowed here. Because we are using the where clause, the where only operates on single rows, whereas the having will operate on grouped rows. So I can uncomment the having statement, and if I comment out the where clause and run the query will work. Now, having is always recommended to use after the group by clause. You can use the having statement above the group by. So for example, if I do Control C and come here and paste it, Control V, and comment out the having clause here. Now, if I run the query, I will still get back a result. But it's always recommended to use the having clause after the group by clause, because when running the query, the group by statement will run first. So when working with having and where, you have to be very careful how you use the where clause together with the having clause. Having null values in a table can present a few challenges. You can face data integrity, query complexity, performance issues, even unexpected results. The NVL functions will allow you to substitute a variable when a null value is encountered. You can convert numbers, date, and varchars. For example, if I run this query, you would see that some of the employees in the commission PCT column has null values. That means they do not collect a commission. And if I scroll down, you would see that some employees do collect a commission. Now, when you're doing any type of arithmetic expression on a column that contains null value, the result will always be null. For example, if I calculate the salary column together with the commission PCT column and I run the query, you can see the result for the employees who do not collect a commission. Their results remain as null, whereas the employees who do collect a commission, their values has been added. In this case, we want to remove null from the employees who do not collect a commission and substitute it with a value of 0. First, I'm going to use the NVL function to substitute the value to 0. So around the commission PCT column, I'm going to say, whenever you meet a value inside of this column as null, I want you to substitute it to 0. So if I go ahead and I run this query, you would see that in the commission PCT column, which is this one here, the value has been changed to 0 for all of the employees whose value were null previously. Now I can go ahead and do a proper calculation on the commission PCT column together with salary. So I'm going to put a bracket or a parenthesis around salary plus commission PCT, and I'm going to use the NVL function, and I'm going to use the same expression as we have here. So I'm going to say whenever you meet null values, I want you to substitute it to 0, and I'm going to close off the parenthesis. Now, this is a better way to do any type of calculations on a column that contains null values. Now I'm going to run the query. You can see that the column now has been calculated properly. The NVL2 function allows you to specify different values depending on whether a null value is encountered or not. In this example, I'm going to print the last name, the commission PCT column, and I'm going to do some arithmetic expression on the salary column together with the commission PCT column. Now, I'm using the NVL2 function, and what this will do, it will look inside of the commission PCT column, and anyone who collects a salary, it will add 1.1% to their salary, and the employees who do not collect a commission, it will substitute the value to 0 instead of remaining as null. I'm going to run this query, and if we look at the results, the employees who do not collect a commission, their value is 0 for salary, whereas the employees who collects a commission, 1.1% has been added to their salary. The null-if function in Oracle SQL is used to compare two expressions. If they are equal, the null-if returns null. If they are not equal, it returns the first expression. If I want to use the null-if function, I can say null-if, and inside of a parenthesis, I'm going to use the NVL2 function. So I'm going to copy this part of the statement and I'm going to paste it inside of the null-if function, and then I'm going to say 0. So what the null-if function is doing, it's going to do the calculation of the NVL2 function. Now, if the equation of the function is 0, so if this 0 and this 0 is equal, it's going to return null to the row. If after the NVL2 expression not equal to 0, then it's going to do salary times 1.1. Now I'm going to run the query, and you can see here all of the values from the NVL2 expression is 0. That means it's equal to the 0 in the null-if function. So it's going to return null. And for the ones who do not equal to 0 after the NVL2 expression, it's going to add salary times 1.1, which is this number here. Now let's take this number for example, 15400, and we're going to put it here, 15400. I'm going to run the query again. If I come down, you see it here, it says null. So basically it's looking for any column that matches this expression. The coalesce function returns the first non-null or not null expression amongst its arguments. It is particularly useful when dealing with potential null values and you want to provide a fallback option. For example, in this query, I'm going to add the coalesce function, and inside of the apprentices, I'm going to use the commission PCT column. And I also want to add the manager ID column as well. And I'm going to add 0 at the end. So what this expression is doing, it's going to look to see if the commission column has null values. And if it does, it's going to print the manager ID. If both commission PCT is null and manager ID is null, it's going to substitute the value to 0. So if I run this query, if we look at the result, the manager ID is displayed because the commission PCT column is null. Now, if I scroll down a little bit more, the commission PCT column has a value, so it will display the commission PCT column instead of the manager column. Remember, for the coalesce function, it goes in order. So it's going to look for the commission PCT column first to display. If it finds any null value, then it will display the manager ID. Now, if I scroll all the way back up to Stephen, in the commission PCT column and also for manager ID, it's both null, so the value will display as 0. Now, if I come by the commission PCT column and I say manager ID and run the query again, we can see that Stephen commission PCT column is null. Also, the manager ID is null as well. So the value was substituted to 0. The case expression and decode functions are the two methods in SQL that helps us with conditional expressions. I'm going to start with the case expression. The case statement is used to add conditional logic to your SQL queries. It is similar to the if, then, else logic in programming. For example, I have a table in my database called countries, and inside of the countries table, we have 3 different columns: country ID, country name, and region ID. Now, if I want to add some tax stipulations on some of the countries, I can do that with the query select. And for this example, I'm going to select country ID. I also want to display the country name, and here I'm going to use the case statement. So I'm going to say case, and with the case statement, I'm going to say when country name is equals to, inside of single quotes, I'm going to say Canada. Then I want to add tax of 13%. So I'm going to say add 13% tax. And I'm going to close it off with the single quote. I'm also going to look for China as well. So I'm going to say when country name is equals to China, then add 15% tax. And the last one that I'm going to look for is United States of America equals to United States of America. Then I'm going to add 5% tax. And for the else, I'm just going to say no tax. And for the case statement, you must end it with the end statement. And I'm going to rename this column as taxed countries. And I'm going to pull that information from the countries table. Now I'm going to run the query, and if we look at the results, whenever it meets Canada, it says add 13% tax. When it meets China, it said add 15% tax. If I scroll down, when it meets United States of America, add 5% tax. And for all of the other countries, no tax. The decode function provides functionalities similar to a simple case statement. It allows you to perform conditional check and return corresponding values. For example, I have this statement. Instead of using case, I can use decode. And with decode, I do not need the else statement. And I would have to put inside of parenthesis. And I also do not need the end statement as well. With decode, you have to specify the column name you want to use. I'm going to use country name, and then I can delete all of these lines. I'm going to put a comma. We do not need the then statement. All you need is a comma in between the two values. And at the end of each, I'm going to put a comma as well. So for readability, I'm just going to put tab. So for decode, all you have to do is use the decode function, and then you're going to say which country or which column you want to operate on. So we're going to look for Canada, China, and United States of America and apply some condition. We can also provide default values. So the default value will be no tax apply, and we're still going to name the column taxed countries. Now I'm going to run the query, and here it says no tax apply, which is for the default value, and then wherever it is Canada, we still add a 13% tax. United States, we add 5% tax. So the difference between decode and the case statement is simply just how you write out the syntax. The case is more flexible and readable, while decode is more compact. Another difference is the usage. The case can handle more complex conditions, and it is part of the SQL standard, whereas decode is specific to the Oracle database. Sometimes you may need to use data from more than one table. Joins allows us to combine rows from two or more tables based on a related column between each table. There are several types of joins, each serving different purposes. In SQL, you have natural join, self join, cross join, left join, right join, and full join. To create a join in SQL, there are some rules and syntax that must be followed. First, you have to make sure that both tables have a relationship between each other, hence a relational database. For example, if I want to join departments table together with the employees table, I have to make sure that there is a column in the departments table that correlates to a column in the employees table. In the departments table, I have a department ID, and in employees table, I also have a department ID. So right there, I know I can join those two tables together using the department's ID column. The data that's in the department's ID in the department's table is the same data in the department's ID in the employees table. The department's ID in the department's table is the primary key, and the department's ID in the employees table is the foreign key. Now, I also have a manager ID in the employees table and a manager ID in the departments table. However, it is always recommended when you are joining tables, use the primary key and the foreign key. I want to print some information from the employees table and from the departments table. The query to do that will be select, and I'm going to say e dot last name, because I want to print the last name column in the employees table. When joining two or more tables, you need to qualify the names of the columns with the table name to avoid ambiguity. So without the alias, it will be hard to distinguish which column is from which table. For example, I have a job history table, which have a job ID, I have a jobs table that have a job ID as well. And I also have a job ID in the employees table. So the job ID in the jobs table will be my primary key, and in the job history and in the employees table, that will be my foreign key. So how will SQL developer knows which table I'm trying to grab the job ID from to create the join? I want to pull the last name column from the employees table, and E will represent the employees table. Now you can name your alias any name you want. Preferably, I like to name my alias the first letter of the table name. So I'm going to say E.lastname. And I also want to grab the salary column from the employees table as well. So I'm going to say E.salary. So these are the columns that I need from the employees table. Now I'm going to join the departments table, and I want to print the department name in this query. So I'm going to use D as my alias name, which represents departments. So I'm going to say D dot, and I want to print the department name. It is recommended that when listing columns from a specific table, you do it in order. It's not readable if we move salary to this side of the query. So that means that we printing from the employees table, then it will go to departments table, then it will come back to the employees table. It's not recommended to do that. It's always recommended to list the tables in order. Now that I have all of the tables that I want to print from the query, I'm going to tell SQL developer where to get this data from. So I'm going to say from employees E. You have to specify which alias is associated with which table. So I'm telling SQL E is associated with the employees table. Then I'm going to use the join keyword. You must use the join keyword if you want to join two tables together. So I want to join the departments table. So I'm going to say join departments, and I want SQL developer to associate D with the departments table. Now you have to tell SQL developer which column do you want to use to join the two tables. In this example, we're going to explicitly say to SQL developer which column we want to join and not choose the column first automatically, because SQL developer can choose the column for you if you use natural join. But this time we want to choose the column ourselves. There are two ways you can tell SQL developer which column you want to use. You can use either the on clause or the using clause. Now, there are some differences when using the on clause versus the using clause. The on clause can join columns with different names, whereas the using clause requires that the columns have the same name in both tables. The syntax will be different for using the on clause and the using clause. First, let's use the using clause. So I can say join department D using, with the using clause, you just specify in the parameter which column you want to use. So I can say department ID to create the join. Now, if we look at the results, we got back our last name column from the employees table, salary from the employees table. If we look in the employees table, we do not have a department name. The department name is in the departments table. So here it prints the department name for us from the departments table. Now, if I want to join the table using the on clause, the syntax will be different. I'm going to delete the using statement, and I'm going to say on, and I have to use the alias in order for me to join the tables using the on clause. So I'm going to say E dot department ID, and I have to use the equal sign. So I'm going to say equals to D dot department ID. Now, when I use the equal sign, it is called an equal join. I'm going to run the query. If we look at the results, we still get back the same information as we did when we used the using clause. A natural join is a type of join that automatically combines columns from two tables based on columns with the same name and compatible data type. Natural join automatically detects and joins matching columns without explicitly specifying them in the on or using clause. However, it can be a bit risky since it relies on column names matching exactly. For example, in the database, I have a countries table and I also have a locations table. In the countries table, you have the country ID, which is the primary key. And in the locations table, you have a country ID, which is the foreign key. So those two tables can be joined. So if I want to join these two tables together, I can say select, and I'm going to select everything in the table. So I'm going to say star, and I'm going to have my from clause. So from countries, I want to natural join locations. Now, if I run the query, I will get columns from the countries table, which is country ID is right here, country name here, and region ID. It will also print location ID, street address. If I scroll over, I also get postal code, city, province, and it did not print the country ID for the locations table. Instead, it prints the country ID that was in the countries table. A self-join is a type of join where a table is joined with itself. This is useful when you need to compare rows within the same table or create a hierarchical structure. For example, if I want a list of manager names and the employees that worked for them, because the manager and non-managers are all employees, the manager do have an employee number. So there is no need to create a separate table for managers. So the manager can go together with the employee table. After all, the manager is still an employee. The query to do that will be select, and I'm going to say E. So E is an alias to let SQL developer knows that we want the employee ID in the employees table. Dot, and then I'm going to say employee underscore ID. I also want to show the employee's last name, so I'm going to say E last name, and that means I'm telling SQL developer get the last name from the employees table. I also want M, so M is for manager, so I'm going to say last underscore name. Now we do not have a managers table, but in this situation we are doing a self join, so I'm trying to grab the manager's last name, and I also want to grab the employee's last name as well. So I'm going to say M, which is my alias for manager, and last underscore name. And I also want the manager ID. So I'm going to say M dot manager underscore ID. So I'm going to say M dot manager ID, and I want to get this from. Now, this is where you're going to use the aliases for joining. So I'm going to say from employees table E. I want to inner join employees M. Then I'm going to use the on operator. On tells SQL developer or which column to use to join both tables. In this situation, we are joining the table to itself. This is called a self join. So I'm going to say E dot manager ID goes to equals to M dot manager ID. So I want to see the manager ID and the employees who worked for them. So this is the employees portion and this is the manager portion. Now I'm saying from employees E, which is the alias. So it knows to get the employee's information. I want to inner join. I'm still joining the employees table, so I'm joining it to itself. And M will be the alias. So that means I want to grab the manager's information. And the reason why I want to grab the manager's information and I'm joining the table to itself, because managers are still employees. So the manager will also have an employee ID. And then I'm using the on operator. It's telling SQL developer which column to use to join the table to itself. So I want to join E dot manager ID, and I want to equal it to M dot manager ID. This situation is rare. You would rarely get a situation where you need to join a table to itself. However, it's always good to know how to do that in case you come up on a situation where you need to use it. So I will go ahead and run this query. If we look at last name for both columns, this is the employee last name and this is the manager's last name. So if I come here and create an alias and I say as emp underscore last name, and here I can say as mgr last name. Now this is a little bit more readable. Now if I rerun the query, so here is a list of all of the employees with their managers and also the manager ID. A non-equal join in SQL is a join condition where columns from two tables are compared using operators other than the equal sign. These operators can be less than, greater than, less than equal to, greater than equal to, not equal to, or other comparison operators like between and or. Non-equal join are useful when you need to match rows based on a range of values or non-equal condition. For example, in the employees table, we have a salary column. In the jobs table, we have a mean salary and a max salary. Now I can join those two tables using salary column in the employees table and mean and max salary in the jobs table, because the data types for both columns are the same for salary with mean salary and also salary and max salary. So to explain that, I will go ahead and write the query. Select E. Now E is an alias for the name of the employees table. So I would say E dot last name. I also want to pull the salary column. So I'm going to say E dot salary. Now I want to display the job title as well. So I'm going to join this table. I'm going to say J dot job title. Now in the from clause, I'm going to say from employees E, which is this table here. We're going to get that information from. When I want to print the job title, because I'm going to grab that information from a different table, I'm going to say join jobs J. And remember, J is our alias. For this example, I'm going to use the on operator. So I'm going to say on E, and I have to say which column I want to use to join those two tables together. Now I can say E dot salary, and I want my salary between mean and max. So I'm going to use the between operator. So I say between J dot mean salary and J dot max salary. Now if I run the query, I would get back the last name, salary, and job title for the employees. So this type of join is called a non-equal join, which means I am not using the equal sign. I can also say where salary greater than J dot mean salary. Now if I run the query, it will show me everything that is greater than mean salary. A left join, also known as left outer join, is used in SQL to retrieve all rows from the left table and the matching rows from the right table. The table that follows your from keyword is always the left table. The right table is the one that comes immediately after the join keyword. I have this query on my screen, which is a regular join. So if I run this query, it will join the employees table with the departments table. Now, if I want to do a left join, I can come where the join statement is at line number 3 and say left join departments to distinguish which table is on your left and which table is on the right. The table that follows the from keyword is always the left table. So in my situation, employees is my left table because it follows the from keyword. Now, some people may also say in the select statement, the table that comes right after the select statement will be your left table, and then it will go to your right table, which is the departments table. However, people can mix the columns together, so I don't necessarily go by the select statement. I always go by the from keyword. So the table that follows the from keyword will always be the left table, and the table that follows immediately after the join is your right table. So my right table is departments. If there is no match, the result will include null values from the column from the right table. Because I'm doing a left join, the priority will be for the left table, which will be my employees table. So it's going to print all the data from the employees table, and any data that is missing from the departments table is going to be null because the join is not prioritizing the right side of the table. It's prioritizing the left side of the table. Now let's run this query, and if we scroll down, we can see that Grant have some missing values. So Grant doesn't have a department ID and also a department name. So his value will come back null. To right join the table, we can say right, and this will right join the departments table. So in this situation, departments will be prioritized because we are right joining the table. The employees table will still be the left table, and departments will still be the right table. So it will print all of the information in the departments table, and it's going to try to match the information in the left table, which is the employees table. So any information that is missing or not matching with the departments table, it's going to print null. Now let's run this query. And if we scroll down a little, we will see that some null values has been presented from the employees table. A cross join is used to produce the Cartesian product of two tables. Cartesian product is a set formed from two or more given sets. This means that every row from the first table is combined with every row from the second table, creating all possibilities combination of rows. It is useful in scenarios where you want to generate pairings or explore all possibilities between two data sets. To create a cross join in SQL, all you have to do is say cross in front of the join keyword. And with a cross join, you don't use the on keyword or the using keyword. So we are going to delete the on statement, and then we're going to run the query. And here you can see it fetch a numbers of rows for us. If we take a look at the results, we can see that the cross join combines every data from the first table, which is our employees table, to the data from the second table, which is the departments table. A full join, also known as a full outer join, is a type of join that combines the results of both left join and right join. It returns all rows from both tables, including matched rows and unmatched rows. When there is no match, the columns from the non-matching tables will contain null values. So for example, if I want to do a full join with the employees table and the departments table, I'm just going to say full right before the join keyword. And if I run the query, the results from the left join is showing, and we also have results from the right table as well. A subquery, also known as an inner query or nested query, is a query embedded within another SQL query. Subqueries are enclosed in parentheses and can be placed in various clauses such as select, from, or where. Subqueries are powerful tools in SQL that allows you to break down complex queries into manageable steps. For example, if I want to find all of the employees who makes less money than Russell and have the job ID as employee 144, I have to go through 3 different steps or get 3 different information in order for me to get the result that I want. First, I have to find how much money Russell makes. Second, I have to find all of the employees who makes less money than Russell. And third, I have to find all of the employees who have the same job ID as employee 144. First, I'm going to find out Russell's information in the database. I'm going to say select salary from employees where last name equals to Russell. So with this statement, SQL developer is going to look for Russell's salary. Now I need to find out all of the employees who makes less money than Russell. I'm going to go above the select statement and create another select statement. And that select statement is going to be for the employees who makes less money than Russell. So for this query, I'm going to say select, and I want first name, last name, and salary. And I want to get this information from the employees table. And for my where clause, this is where you create a subquery. So for this query, I want to say where salary is less than. And with a subquery, you must enclose it in parentheses. So I'm going to put my open parentheses here, and then I'm going to put my closing parentheses. So this is the first 2 steps that we need to do so far. First, we need to find out Russell's salary. So this is called the inner query. Then I need to find all the employees who make less money than Russell, and this is called an outer query. Now, the less than sign is just going to say find the employees that make less money. If you want to find the employees that make more money, you would do the greater than sign. If you want to find the employees who make the same money as Russell, then you can use the equal sign. Now I need to write another query to find what's employees 144 job ID. So I'm going to come to the bottom and I'm going to use the AND operator, and I'm going to say AND job ID like, and I'm going to use the open and closing parenthesis. I'm going to write my select statement to find out what's employee 144 job ID. So I'm going to say select, and I want to select the job ID from employees where employee ID equals to 144. I'm going to give a tab for readability for the inner queries. So I'm going to go ahead and run the query. And if we look here, we got back all of the employees who make less money than Russell and has the same job ID as employee 144. If I come to the bottom and write a simple select statement to pull employees 144 job ID, select from employees where employee ID equals to 144. Now, if I run this statement, I can see that employee 144 job ID is a ST Clark. Now, if I come back to my statement and print job ID in the first select statement, and I'm going to comment this statement. I'm going to run the statement again. You can see that everyone in the result job ID is an ST Clark. Now, why would you want to use a subquery when you can just get all the information manually? You have to know that querying the database can be costly. I know some people, they would run this select statement first to find Russell's information. And we see here Russell make 14,000. Then they would go to the next select statement and say where salary is less than 14,000 and run this query. And they will get back everyone who makes the salary less than 14,000. Now, this is the second time I'm querying the database, and that can be costly. To avoid all of these steps, you can just simply use a subquery and you query the database only once. Before you start writing code to create tables in your database, it is always recommended to create an ERD. An ERD stands for Entity Relationship Diagram, and it is used to illustrate the relationships between tables in our database. On my screen, I have 4 tables that we are going to create. I have a customer, order, product, and a product order table. Let's take a look at the customer table. In the customer table, we have customer ID, last name, first name, and email. These are going to be the names of the columns in that table. On the right of the columns, I have number and varchar. Number and varchar are the data types that is expected for the specific column. So for example, the customer ID data type is a number. So if I put anything other than a number, for example, if I put strings or special characters, it will result in an error. On the side of the varchar for last name, first name, and email, the 20 represent the amount or the limit of characters I can put in that specific column. If I use 21 characters, it's going to result in an error. When naming tables in SQL, there are some rules that must be followed. Failing to follow rules will result in an error. Here are some of the rules when naming tables in SQL. Table names must be between 1 and 30 characters long, must begin with a letter, must contain characters uppercase A to Z or lowercase a to Z, 0 to 9, underscore, hash symbol, and the $sign. Table names must not be an Oracle Server reserved word. For example, select, where, join. Table names must not be a duplicated name of another object owned by the same user. There are some best practices when naming tables in SQL. It's not compulsory, but most developers follow this convention for readability and clarity. Some conventions when naming tables are using descriptive name. For example, table names should be clearly indicated what the purpose are or the data that they store. For example, if you're storing customers' information, it's best to name the table customers. If you're storing order, it's best to name the table orders. Or if you're storing products, it's best to name the table products. When naming table, it is always advised to stick to alphanumeric characters. For example, avoid space, avoid special characters or symbols in table names. Use underscore if you need to separate words. Be consistent with case. Decide on a case style and stick to it throughout the database. For example, if you're using snake case, which is lowercase, underscore, lowercase, or Pascal case. Also, when naming tables, keep in mind the singular words versus the plural words. Choose whether you want to use singular or plural names for tables and apply it consistently. For example, customer versus customers, product versus products, order versus orders. Normalization is a core database design principle used to organize data efficiently. Its main purpose is to reduce redundancy, prevent anomalies, and ensure data integrity. Normalization breaks large unstructured tables into smaller relatable tables, following specific rules known as normal forms or NF. When a database is not normalized, it can lead to duplicate data, update errors, inconsistent record, and difficulty scaling. We have up to 6 normal forms, and we also have DKNF, EKNF, and BCNF. But for this tutorial, we're going to focus on 1 to 3 NF because these are the most used normal forms in business. Let's take a look at first normal form, also known as 1NF. The rules are each cell must contain a single value, no repeating groups or arrays, and every record must be unique. For example, customer ID 1, whose name is John, has 2 phone numbers stored in the phone numbers column. This violates first NF or first normal form. Each record must be unique, no repeating groups or array. To fix this problem, we would have to create a second record for John or a second row for John, and this can be accomplished by using a primary key. So once we have a primary key on the customer ID column, we can go ahead and create a different row for John to store his second number. Let's take a look at second normal form. The rules are must be in first NF. All non-key columns must depend on the entire primary key. And this applies when the primary key is a composite key. Let's take a look at this example. Let's say we have a product order table. And right away we can see we have 2 primary key in this table. We have order underscore ID and product underscore ID. Both order underscore ID and product underscore ID are primary keys. But on this table, they are composite key because 2 of the primary keys are composite key. So in this table, the primary key is also a composite key. Now we have product name or the name column. So in this situation, the name column only depends on the product underscore ID, which is just part of the key. So this creates a partial dependencies which violates the second normal form. The name has to be fully dependent on product ID and order ID, but the name does not. The name only depends on the product ID. So the only way to fix this is to create another table, and we're going to move the name column into the new table. So we can create a table called product, and we're going to move product ID. So that table is going to have a product ID as well. And we're going to move name into the product table. We're going to create a new price column in the product order table. The reason for creating a new column called price underscore top, let's say for example, the company changed the price of a product. We still need to know the previous price of that product or the history of that product. We are going to create a new column called price underscore top for time of purchase. And then in the product table, we're going to create a price column to keep track of the latest price. And this is how you move from first normal form to second normal form. Let's take a look at third normal form. The rules, it must be in first normal form. Once it is in second normal form, then we already know it's already in first normal form. And no transitive dependencies. So non-column key must not depend on other non-column keys. No transitive dependencies. That means none key columns must not depend on other non-key columns. Let's take a look at an example. Let's say we have an employee table and we have an employee ID, name, department, and department phone number. Now the issue here is department phone number depends on the department, not directly on the employee ID. So if the HR department, for example, changes its phone number from, let's say, 44-3040 to 445040, you will need to update every employee in the HR table. This will create update anomalies. How? Let's say if you miss one row or you mistakenly delete something. This can create inconsistent data. So the solution for this will be creating another table. We can create a table called department, and we're going to put department and phone number in that department table. That way, the telephone number is depending on the department. To download SQL Server, we're going to go to Google and type in SQL Server. And you want to click on the first link that shows up from Microsoft.com. So we're going to click on SQL Server Downloads, and it's going to take you to this screen. When you get to this screen, you're going to scroll down and you would see two options, Developer and Express. We want to download the Express version of SQL Server. So I'm going to click on Download, and this is going to download a package for us. We're going to double click on the package to open it up. Now, once we click yes, it's going to open up this screen. This is the SQL Server 2022 Express Edition. Now we have three options: basic, custom, and download media. For this tutorial, we're going to use the basic version of Express Edition. So we're going to click on basic. It's going to ask us to accept the terms and condition. We're going to click on accept. And this part here shows you exactly where the file is going to be downloaded. If you do not have any valid reasons for changing the file location, I suggest that you leave it in the program files folder. So I'm going to go ahead and click install. Once the installation process is completed, you will get this message. On the connection string, you may want to copy the connection string and paste it somewhere in your notes. The rest of the options, you can leave it as it is. Now, if we go to the bottom of the screen, you can test the connection by clicking on Connect Now, and you will get to this screen. If the installation has completed successfully, you will get this screen. If you get an error, that means you have to reinstall SQL Server again. Once we have established a successful connection, we can go ahead and click on Install SSMS, and it will bring up this screen for you. You will want to scroll down on the Download SSMS and click on Download SQL Server Management Studio. And once you click on it, it will download this file for you. Once download completed, we're going to open the file. If you do not have any valid reason for changing the file location, I suggest you leave it as it is and click on Install. And this will download the packages that we need to run SQL Server Management Studio. Once setup has completed, you can go ahead and click on Close. Once you have completed downloading Microsoft SQL Server, we're going to click on the Start option, and then we're going to look for SQL Server Management Studio. If it's not there in the recommended section, you can click on All and then scroll down till you meet Microsoft SQL Server. You're going to click on Microsoft SQL Server Tools, and on the tools you will see SQL Server Management Studio and the number. We're going to click on that, and it will take you to this screen. When you get on this screen, this is just the connection to the SQL Server. Leave all the options as is. However, under the connection security, you want to click on Trust Server Certificate and then click on Connect. Once you click on connect, you will get to this screen. In the above pane, there are tools and options to help you better use the application. In the second row, you can create a new project. You can open an existing project, save all tab, new query, data engine query, and you also have analysis services such as MDX, DMX, XMLA, and DAX. In the second row, you have the execute option together with the cancel and pause option plus more. This section has been blocked off because you need to create a new query. Once we create a new query where we write the code, then this section will be unblocked for us to use. But before I click on new query, let's take a look at the Object Explorer pane. Under the Object Explorer pane, we have connections which allow us to connect to a database engine, analysis services, integration services, reporting services, Azure Storage, and Azure SSIS integration runtime. You also have Connection Object Explorer and to disconnect from the database. And you also have the refresh button that we're going to use a lot during this tutorial. On the connection, you should see your computer name or the name of the connection. If we click on the plus icon, it will give us other objects that is available under these connections. For example, database, security, server objects, replications, management, and event profilers. For now, we're going to focus on the database option. If we click on the plus icon besides database, we will see system databases and database snapshots. If we look on the system databases, we will see several databases that is default with the Microsoft SQL Server Management Studio. So we have master, model, MSDB, and tempdb. If we go back to the top, we have the new query option, and you're going to click on that option, and this will give us an environment to write our code. Now, when the text editor open, you would see a lot of the other options that was blocked off is now open to use, or it's now clickable. Before we go on to writing code, you can personalize your setup. If we look at the top, it will say SQL query 1.sql. This is the name of the file that you're working with. So you can always change the name of the file when you go to file and you click on save. You have the opportunity to rename that file to whatever you want. So let's rename the file. We're going to click on save and we're going to rename this file. First, you want to make sure that the file is saved in the SQL Server Management Studio. And instead of saying SQL query 1, we're going to put SQL _ tutorial and make sure that the extension is .sql, and then you hit save. When you click save, now you can see the name of the SQL file has been changed to SQL _ tutorial.sql. You can customize your environment by clicking on tools, options, and on the environment, you can change some of the options. Now let's look at fonts and colors. If you want to increase the size of the font, you can increase it under the size option. If you want to change the font body, you can do that here as well. Once you finish, you can go ahead and click on OK, and it will save and change the new environment. In this section, this is where you're going to write all of your SQL code. If we look at the available databases, you can see that we're currently in the master database. If we click on the drop-down menu, we have master, model, MSDB, and tempdb database available. However, it is always recommended to create your own database based on the data you're storing. But before we start writing any code and creating a new database, let's look and see who is connected to the database. And to see that, you can use the query sp _ who2, and we're going to highlight and press execute. When we press execute, if we look at the bottom of the screen, this is our result pane. In the results, you can see everyone who is currently connected. To create a database, you can use the query create database, and you have to give the database a name. So we're going to name the database my shop, And we're going to highlight the command and press execute. Now, if we look at the result pane, it will say command completed successfully, and it will also give you a completion time. If we go back under the Object Explorer, you're going to see the refresh icon. You want to click on it and it will refresh our database. Now, if we go back on the databases, you would see my shop database. Now, if you want to use your database or move to your database in order for you to create objects, if we click on the available option, drop down menu, you would see your database that you just created, which is my shop. So this is one way you can get into your database. However, if there are many databases, it's easier to use the command. And the command to move into your newly database is use and the name of the database. So I'm going to say use my shop. I'm going to highlight the command and click on execute, and this will change our database. So you see right away when I click on execute, it moves me into the my shop database. To drop the database, you can use the command use master, go, drop database, and the name of your database you want to drop. So let's drop the my shop database and then go. We're going to highlight the command and press execute. And in the bottom, it says command completed successfully. Now, if we refresh and we click on databases, we can see that the database that we just created is gone. If I click on available databases, I no longer have the my shop database. I'm going to delete the command and write it one more time so you can get familiar with writing the code. So to create a database, you use the command create database and the name of the database. We're going to still call our database my shop. And if you have a single line of command, you can hit the execute button without highlighting the command. So let's click on execute. And here we can see that command completed successfully. If I go back and I refresh and click on databases, I see my shop database now available. Now let's use the database by saying use my shop. And I'm going to run the query. And now we're in the my shop database. When creating tables in SQL, you want to ensure that you're creating the tables in the correct database. If we go under available databases, we will see the options master, model, MSDB, my shop, and tempdb. You're going to select the database that we have just created called my shop. To create tables in SQL, you use the keyword create table and the name of the table. So we're going to create a customer table and open and close in parentheses, and then you're going to use a semicolon. The semicolon let SQL Server know that this is the end of the create table statement for the customer table. Inside of the open and closing brackets, we're going to list the name of the columns together with the data type and the constraint, if any. So the first column we're going to create is the customer ID, and the data type for customer ID will be an integer. In this example, we're also going to use the customer ID as the primary key. This constraint will ensure each row has a unique identifier. That means no two customers can have the same ID. There are two ways you can apply constraint on a table. You can apply constraint on a column level or a table level. A column level defined at the time of the column creation, and it can be only applied to a single column or a specific column. Whereas table level is defined after all columns has been declared and it can be applied to one or more columns. Let's take a look at how to apply constraint on a column level. The constraint we're going to apply is the primary key, and we're going to put the primary key constraint directly on the customer underscore ID column. And by doing that, we just declared a constraint on a column level. After primary key, you're going to use a comma, and the comma tells SQL Server this is the end of the query. Go to the next line. The next column we're going to create is name, and name is going to have the data type of varchar. And inside of open and closing bracket, we're going to put a limitation of characters for the name column. The limitation will be 20. So that means that the name column must hold maximum of 20 characters long. Then we're going to use a comma, go to the next line, and the last column we're going to put in the customer table for now will be email. The data type for email will be a varchar as well. And being as email usually longer, because some people use first name, last name together with special characters. So the email will be up to 50 characters long. After the last column in the create table statement, we do not use a comma. So this is the syntax to create a table in SQL. Now we are going to hit the execute button, and it will say command completed successfully. If we refresh the database and we click on databases, my shop tables, we will see the customer table, which is dbo.customer. DBO means database object. Now let's go ahead and create the remaining tables. So we are going to create the product table. Now we are going to create the product table. So we are going to say create table product, and inside of open and closing parentheses, we're going to list the columns together with the data type. So for the product table, we want the column product ID. So we're going to say product underscore ID, and the data type for product ID will be an integer. Product ID will have a constraint, so we're going to use the product ID column as the primary key for the product table. So we're going to say primary key, and we're going to give a comma. We're going to come down to the next line. We want name, and name will have the data type varchar, and we're going to limit the product name to 100, comma, come down to the next line, and we want price. Price is going to have the data type decimal, and for decimal, we want the limit of 10 digits and 2 digits after the decimal point. Let me run the command. So I'm going to highlight it and press execute. The next table we're going to create is the order table. So we're going to say create table order, and open and closing parenthesis and a semicolon. Inside of the order table, we're going to list our column names together with the data type and the constraint. So for order table, we're going to say order underscore ID. This is going to be our primary key column, and the data type for ordered ID will be an integer, and we're going to say primary key, comma, go to the next line. The next column will be customer ID. The data type for customer ID will also be an integer. We're going to give a comma, order date, and the data type for order date will be date. Now we want to link the order table with the customer table. So to do that, the customer ID will be a foreign key inside of the order table. Now we're going to link these two tables by using customer ID column. So to do that, we go to the bottom and we say foreign key, and we want to tell SQL Server which key we're going to use as the foreign key. So the key is going to be customer ID, and we want to tell SQL Server where it can reference the customer ID column. So we're going to say references, and the table we want to reference. So we want to reference the customer table, and we're going to say which column in the customer table we want to use to create the link between customer and order. So we want to use the customer ID column. Now, if we look at the create table command, we can see that order has a red squiggly line underneath. Usually that means that if we press the execute button, it's going to give an error. If you want to remove this error, all we have to do is just rename the table. Now let's try it without renaming the table first and see what error it is giving. So we're going to select the create statement for order, press execute, and here it says incorrect syntax near the keyword order. This usually means that this word is not acceptable. So all we have to do is just change it to order M, and we're going to highlight again and hit execute, and there we have command completed successfully. Now if we do a refresh, go on the databases, my shop database, tables, we will have the customer table, order M table, and the product table we just created. Now let's go ahead and create the last table, which is going to be the order product table. To do that, we're going to use the keyword create table, order product, open and close in parentheses, together with the semicolon. Now the columns that we want in the order product table will be order ID. The data type for order ID will be an integer, comma. Then we want product ID. Product ID will also hold the data type int. We also want a quantity column, and that will be an int. The second way to add constraint to your column is by table level. Table level constraint are written separately after all columns are declared. So we want to use the order ID as a primary key. So we will come down to the bottom of the column list and say primary key. And we want to tell SQL Server which column in our table we want to use as the primary key. So in this case, it's going to be order ID, order underscore ID. And we also want to use product ID as a primary key as well. So we're going to say product underscore ID, and then we're going to give a comma. So that's the second way you can enforce a key on columns. Now the next thing we're going to do is add foreign keys inside of the order product table. Now to create foreign keys, we can just say foreign key inside of the brackets. We're going to put the columns that we want as a foreign key. In that case, we want the order ID. So order underscore ID as a foreign key, and we have to tell SQL Server which table we want to reference the order ID. So we're going to say references. So we want to reference the order underscore M table, and inside of the brackets, we have to tell SQL Server which column in the order underscore M table that we want to use. So we want to use the order underscore ID column. Now we're going to add one more foreign key to the order product table. So we're going to say foreign key, and we want the product underscore ID column, and it have to reference the product table, and we want to use the product ID to create the link. So I'm going to go ahead and highlight the query and press execute, and we can see that our command completed successfully. Now if I refresh the database, go on the databases, my shop database, tables, we will have all of the tables we have just created. After you create a table, you may need to modify the table structure. The alter table statement allows you to modify an existing table without deleting and recreating it. You can use it to modify an existing column, add a new column, drop a column, add a constraint, drop a constraint, and rename a table. Let's alter some tables in our database. But before we start altering the tables, you want to make sure that you're inside of the correct database. So under available databases, you want to click on My Shop Database. On the left, under the Explorer pane, you would see a list of tables inside of the My Shop database. We're going to do some altering to the customer table. If we click on the plus button next to the customer table and we click on columns, currently we have 3 columns in the customer table: customer ID, name, and email. We are going to add a column called address to that customer table. To do that, the query will be alter table. So we want to alter the customer table. So we're going to say customer, and then we want to add address, and the data type for address will be a varchar. So we're going to say a varchar 50, and then we're going to add our semicolon. We're going to go ahead and hit the execute button. Command completed successfully. Now if we do a refresh and we go under databases, My Shop, tables, we go under the customer table, columns. Now we have the address column added to the customer table. We're going to alter the customer table and add a unique constraint on the email column. That way, every customer should have a unique email address or no duplicated email address. To do that, the syntax will be alter table, customer, add constraint, and we have to give the constraint a name. So we're going to name this constraint UNI underscore email, and the constraint we want to put on the column will be unique, and the name of the column we want to put the unique constraint on is email. We're going to add our semicolon, highlight the query, click execute, and command completed successfully. Now if we refresh, go back to databases, My Shop, tables, under customer tables, if we go to keys, we're going to see our unique constraint that we just created. To drop a constraint is pretty similar to adding a constraint on a column. Let us drop the unique email constraint we've put on the email column in the customer table. To drop a constraint, the query will be alter table, customer, drop constraint, and the name of the constraint we want to drop. So we want to drop the uni underscore email constraint. We're going to put a semicolon, highlight the query, click on execute. It says command completed successfully. Now we have the uni email address still in the customer table. We're going to refresh the database, go back to databases, My Shop, tables. Under customer, we're going to go to keys, and we no longer have the uni underscore email. Now let's put back the constraint, but we're going to change the name to unique instead of uni. We're going to highlight the query. So we're adding back the constraint. We're going to click on execute, refresh, go back to databases, My Shop, tables, and under the customer tables, we're going to check for keys, and we have our updated constraint. To drop a column in a table, it is pretty similar to adding a column in a table. Let us drop the address column we've just created in the customer table. So if we look under Object Explorer, we can still see the address column. So to drop that column, the query will be alter table and the name of the table. And we're going to drop column and the name of the column we want to drop. So we want to drop the address column. We're going to give a semicolon and highlight the query. If you do not highlight the query, SQL Server will try to run the query up above. So you only highlight the query that you want to run. We're going to click on execute. It says command completed successfully. If we refresh, go back to databases, My Shop, tables. Under customer table, we look at columns. We no longer have the address column. So let's put back the address column because we're going to use it in later tutorials. I'm going to click on execute, refresh back my database, and check to see if the column was added. You can modify columns in your table by using the alter table statement as well. For example, in the customer table, we have an email column that can hold a maximum of 50 characters long. Let us change that so it can hold more characters, at least up to 100. To modify a column in the table is a little bit more trickier than the others. To modify a column, we have to use two alter statements in SQL Server. To modify the table, we still need to use the alter table statement. So we're going to say alter table customer. And for the next alter statement, we're going to say alter column email. The data type will still be a varchar, and we're going to add 150 to the column. Let's highlight both alter statement and click on the execute tab. Command completed successfully. Now in our email we have 50 characters long, so let's refresh the database. Go to my shop, tables, customer, columns, and now we can see that the email column has been changed to 150 instead of 50. In other systems like MySQL and Oracle, modifying a column will be a little bit different. In SQL Server, you have to use two alter statements. However, in MySQL and Oracle, you only use one alter statement together with the modify keyword. So for example, if I had to do the same changes in MySQL and Oracle, the command to do that will be alter table customer. And instead of saying alter column, I would just say modify. Modify, the column name will be email, and then I'm going to put the limitation of characters that I want to change it to. Now if I hover over modify, it will say syntax is incorrect. That means SQL Server do not use the modify keyword. They use two alter statements, but for Oracle and MySQL, you have to use the modify keyword. To insert data into a table, you must use insert into statement. Let us insert some data into the customer table. But before we do that, let's take a look at the columns inside of the table. We have customer ID, name, email, and address. To insert the data, we're going to say insert into and the name of the table. So the name of the table is customer, and inside of open and closing brackets, we're going to list the column names inside the customer table. So we have a customer ID column. After customer ID will be the name column, then email and address. Now, if you take a look at the way how I list each column, I list them in the correct way it is in the table. After we finish listing the columns, we're going to use the keyword values. And this is when we're going to enter the values that we want in the table. So you're going to put an open and closing brackets. After, you're going to put a comma. We're going to insert 4 rows of data into the customer table. So what I like doing is putting 4 open and closing brackets. And the last one, we will end it with a semicolon. Instead of the open and closing brackets, we are going to list the data. Now, when you are inputting data, the data must match with the column exactly. So for example, the first column is the customer ID. So the first value in the table should be customer ID. So the customer ID, we're going to start it with 1001. Then you're going to give a comma, space. Then we're going to list the name inside of single quotes. When you are writing strings into a database, it must be inside of single quotes. When you are listing integers, it must not be inside of single quotes. Anything inside of a single quote will result in a string. So customer ID will not be in a single quote. However, name, email, and address, because it's varchar, we have to put it inside of single quotes. So the name is going to be Nikki. Get out of the single quotes, comma, space. Then we're going to list the email. Email must be inside of single quotes. So I'll say nikki@gmail.com. Get out of single quotes, comma, space, another set of single quotes, and then we're going to list the address. So the address will be 121 John Street. We're going to add our next set of data, and I'm listing the ID in numerical order to keep the database in order. So instead of single quotes, I'm going to put the name. The name for this one will be Andrew. I'll get out of the single quotes, comma, space. Then we're going to give a next set of single quotes. Email for Andrew going to be Andrew, DEAN, at gmail.com. Get out of single quotes, comma. Then we're going to give a next set of single quotes with space. Inside, we're going to put the address. So the address will be 34 Elgin Road. The next set of data will be 1003, comma, a set of single quotes. The next name will be Mary. Get out of single quotes, comma, space, a set of single quotes again. Mary's email address will be mary01 at gmail.com. Get out of the single quotes, comma, a next set of single quotes, and the address for Mary will be 21 Jane Street. And the last set of data we're going to input will be 1004, comma, space, a set of single quotes. Inside of single quotes is going to be Mike. Get out of single quotes, comma, a set of single quotes again. Mike's email address will be mr.mike@gmail.com. Get out of single quotes, comma, space, another set of single quotes, and we're going to list Mike's address. So Mike's address will be 91 Carline Road. So this is the syntax to insert data into a table. Now let us highlight the query and hit execute. Now it will say 4 row affected. Now if you want to see the data that we just put, we're going to use the command select star from customer. We are going to highlight the query, hit execute, and we will have the data that we just inputted. Let's insert some data into the order underscore M table. Before we do that, let's look at the order underscore M table. And the columns in here are order ID, customer ID, and order date. So we're going to go ahead and write the insert into statement. And we want to insert into order underscore M. And we're going to list the column names. The columns in the order underscore M table is order ID. We also have customer ID and order date. We're going to use the keyword values, and we're going to add 4 values into the order table. So I'm going to give my open and closing brackets together with a comma, and the last bracket we're going to use a semicolon to end. Now for order ID, we're going to start it off as order 1. If we look under the customer ID, in the customer table, we have customer ID as the primary key. And inside of the order table, we have it as the foreign key. So the data for customer ID in the customer table must be the same data for customer ID in the order underscore M table. So to do that, we're going to give the same value as customer ID in the customer table. So it's going to be 101. And for order date, we want the date to always be the date the customer made the purchase. So to get the exact date, we're going to use the function get date, open and closing brackets. So the open and closing brackets will tell SQL Server get date is a function. Now we're going to go to the next set of data to input. The order ID will be 2. We want the same number what's in the customer table, and then we're still going to use the get date function. And let us do the same for the next 2. So this is going to be 3, 1003, get date, and the last one will be 4, 1004, comma, space, get date. And this is all we're going to input for the order underscore M table. Now we're going to highlight the query and hit execute button. Then you would see 4 rows affected. That means we just inserted 4 rows into the order underscore M table. Now let's take a look at the data to make sure everything is fine. So we're going to say select star from order underscore M semicolon, highlight the query, press execute, and if we look at the order date, it should give us the exact date that is on my system. Another way of inserting data into a table is by using a sequence. A sequence is an object that generates unique numeric values, often used for auto-incrementing primary keys. Sequences are created by using the create sequence statement. If we look under the product table, we have 3 columns: product ID, name, and price. So let's input some data into this table. But for the product ID, instead of manually putting the number, we're going to create a sequence. So to create a sequence, we're going to say create sequence, and we have to give the sequence a name. So we're going to name this sequence ENP underscore PK underscore sec. And then we have to tell the sequence where to start and how much to increment it by. So we can say start with 1 and increment by 1. We can also place a max value, so that means the maximum we want the sequence to increment to. We can use the max value keyword and the max value we want. So we can say 1000. But for this example, we're not going to put a max value on the sequence because you want to keep populating the database. So let's remove max value, and we're just going to have it increment by 1. Now I'm going to highlight this query, press execute. Now we can go and write the insert into statement. So we can say insert into products, and we're going to list the columns in product. So in the product table, we have a product ID, then we have name and price. Now we're going to come down and say values. And for values, we're going to add 4 sets of data to the product table. So now instead of the bracket, we're going to say next value 4 and the name of the sequence. So our sequence name is EMP underscore PK underscore sec. So we're going to just copy the name from here and put it right here. And then we're going to give the product a name. So we're going to say small t-shirt. And the price for that will be $9.99. We're going to do the same for the next set. So we're going to highlight this query and we're going to paste it here. And this product this time is going to be blue jeans -M for medium, $29.99. For the next set of data, we're just going to paste the sequence. The product for this one will be black cap, and it's going to be $15.89. And let's input the last sets of value, and this one is going to be black dress, and it's going to be $29. Now we can go ahead and highlight the query, hit execute. It says 4 rows affected. Now let's go down and write a simple select statement to see our data. So we're going to say select star from product semicolon select. We're going to hit execute, and here we have our product. Now if we look at the product ID, we did not specifically put in the product ID. What we did, we just created a sequence and we said start with 1 and increment by 1, and that's exactly what it did. It started with 1 and it incremented each of the product ID by 1. The last table we're going to add data in is the order product table. So we're going to use insert into order product. And in the order product table, we only have 3 columns. So it's going to be order ID, product ID, and quantity. We're going to use the keyword values, and we're going to add 4 sets of data to this table. The first set of data we're going to add is the order ID. So we're going to have it as 1. The product ID will also be 1, and the quantity will be 2. We want to match the order ID together with the order ID that's in the order underscore M table. Right? So this column and this column has to hold the same exact value. So if we go back to the order underscore M table, we will see the order ID is 1, 2, 3, and 4. So we're going to add this value in the product order table. So we can come here and we can see 2. Actually, let's do it in rows. 3 and 4. We're also going to do the same for the product ID. If we go back to the product table, we started the sequence from 1 and we incremented it. So in the product table, we have the product ID from 1 to 4. So let's do the same here. 2, 3, and 4. The quantity will be, let's add 6. The third set of data, the quantity will be around 10. And the last set of data, let's put the quantity at 20. We're going to select the query, hit execute. 4 rows is affected. Now let's do a select statement to pull the data. So we want to select star from order product. We are going to execute this query, and here we have the information we just put in. We can also insert data into a table by copying the data from an existing table or another table. Currently, we have 4 tables in our database: customer, order underscore M, order product, and product. Let's create a customer backup table, which we're going to copy the data from the customer table into the customer backup table. So in our customer table, we have 4 columns: customer ID, name, email, and address. The customer underscore backup table will have the same columns together with the data type. So let us copy the query and hit execute. Command completed successfully. Now if we refresh the database and go back into databases, my shop, tables, now we have the customer underscore backup table. Now if we do a select star from customer underscore backup, and we're going to highlight and hit execute, no data is currently inside of that table because we just created it. Now let's do an insert into the customer underscore backup table. So to do that, we can say insert into customer underscore backup, and we're going to list the columns that is inside of the customer underscore backup table. So we have a customer ID. We also have name, email, and address. Now we're going to tell SQL Server the data that we want to insert into the customer underscore backup table. We want to grab that data from the customer table. And to grab the data from the customer table, you must use the select statement. So we're going to say select star from customer. We are going to use our semicolon, highlight the query, hit execute, and it says 4 row affected. Now let's go ahead and run the select statement again. We're going to highlight the select statement and we're going to hit execute. And in our customer underscore backup table, we have the same data that is in the customer table. Now let's write another select statement for customer. So select star from customer. We're going to highlight this query, hit execute, and you see here we have the exact same data. You can update the data in your table by using the update statement. The update statement allows you to modify existing records by changing the values of one or more columns. When updating data in your table, you also have to use the set clause, which specifies the columns and their new values. You also have to use the where clause, which will filter out the rows to update. Now, let's go ahead and update the customer table. Before we update the customer table, you have to make sure that you're inside of the correct database. So let's switch from master to my shop. Then let's run a simple select statement to view the data that is inside of the customer table. So we're going to say select star from customer. We're going to highlight the query and hit execute. And here you can see the data that is inside of the customer table. Now, let's go ahead and update the customer table. And we're going to change the email address for customer 1001, which is Nikki. So to do that, we're going to say update, and we have to tell SQL Server which table we want to update. And in this example, we want to update the customer table. And we're going to use the set clause. So we're going to say set, and we have to tell SQL Server which column we want to make the update to. So we're going to say set email, and we're going to use the equal sign, and we're going to give it the new email address that we want for Nikki. So the new email will be nikki_01@gmail.com. So currently the email address for Nikki is nikkip@gmail.com. Now we're going to change it to nikkip_01@gmail.com. And then we're going to use the where clause to tell SQL which customer we want to make the changes to, or which row we want the changes to affect. So we're going to say where customer ID is equal to 1001. Now, if we look at customer ID 1001, that is Nikki customer ID. So we're going to go ahead and highlight the query, and we're going to hit execute. Here it says one row affected. Now let's get the select statement at the bottom. So we want to see what's in the customer table now. We're going to hit on execute. And now here you see Nikki email address has been changed from nikkip@gmail.com to nikkip_01@gmail.com. You can update a table in SQL by using the exact same data from an existing table. Previously, we had created a customer_backup table that contains the exact same data as in the customer table. However, in the customer table, we had made changes to customer 1001 email address. Now, customer_backup table will have the old email address for customer ID 1001. So let's make changes to the customer_backup table so it can contain the updated information for customer 1001, which is Nikki. But before we do that, let's run a simple select statement to print the data that is currently inside of the customer_backup table. We're going to say select star from customer_backup, and we're going to highlight the query, and the email address that's in customer_backup for Nikki is nikkip@gmail.com. So let's go ahead and update the email address in the customer_backup table so it can be the same as what's in the customer table for Nikki. So to do that, we're going to say update, and we have to tell SQL Server which table we want to update. So we want to update customer_backup table, and we're going to use the set clause. So we'll say set email. And when we're grabbing data from another table, we have to use the select clause. So we're going to say set the email address equal to, and inside of brackets, we're going to say select, and we want to select the email column. So select email. I'm going to give it tab for readability, and I'm going to say from, and you have to specify which table you want to grab that information from. So we want to grab the email column from the customer table. And then we have to use the where clause to tell SQL Server where or which row you want to be affected. So we're going to say where customer ID equals to, and we want Nikki's customer ID. So Nikki customer ID is 1001. So this here is coming from the customer table. Now we have to get out of the select statement, and we have to tell SQL Server which customer ID or which row that we want to make that changes to. We want to update Nikki's email. So Nikki's customer ID is still 1001. So we're going to use the next where clause, and we're going to say where customer underscore ID equals to 1001 semicolon. Now let's highlight the query, hit execute. One row affected. Now let's go back and run the select statement again for customer underscore backup. Execute. And now you see the changes has been made for customer 1001. So instead of it saying nikkip@gmail.com, it's now nikkip_1@gmail.com, which is the same data that is inside of the customer table. You can remove existing rows from a table by using the delete statement or the truncate statement. Both delete and truncate will remove data from a table, but they behave quite differently. Let's look at the delete statement. The delete statement is DML, data manipulation language. Now the delete statement, you have to use the where clause, which will specify which row in the table you want to delete. Also, when it comes to rollback, it can be rolled back if within a transaction. When it comes to performance, the delete statement is a little bit slower on larger data set due to row by row logging. The delete logs each row deletion in the transaction log, so it have to log each row that you delete. Now when it comes to truncate behave a little bit different from the delete statement. The truncate statement is DDL, which is data definition language, and the truncate will remove all rows from the table, so no where clause is allowed. Truncate does minimal logging. It can be rolled back only if used inside of the transaction and not yet committed. It does not activate the delete trigger, and when it comes to performance, it is much faster for large table. I'm going to run a select statement on the customer underscore backup table. So I'm going to say select star from customer underscore backup. I'm going to highlight and hit execute. And this is the data that we have here. Let's delete Mary. So to delete Mary's information, we're going to say delete from customer underscore backup. And we're going to use the where clause to tell SQL which row in the customer underscore backup table that we want to delete. So we want to delete customer ID. So we're going to say where customer ID equals to 1003. You can also say where name equals to Mary. However, you don't want to use the name column because you can have other customers or multiple customers with the name Mary. So it's always best to use the customer ID or any column that is unique. So customer ID column is a unique column. So if we say 103, we definitely know only Mary with the customer ID 103 will be removed. Let's go ahead and run this query. We're going to hit on execute. It says one row affected. Now let's run the select statement again for customer underscore backup table. And here we see that customer 103 is gone. Now that's how the delete statement works. It will be a little bit different to delete rows that have constraints on them. Soon we're going to see how to delete rows with constraints. Truncate statement will remove all the data inside of the table, but it will leave the structure of the table. Let's use the truncate keyword to delete rows in the table. So to remove all rows from the table, you can say truncate table and the name of the table. So the name of the table will be customer underscore backup, and let us highlight the query and hit execute. Command completed successfully. Now let's run the select statement again on customer underscore backup. And you can see here we still have the table in our database. However, we do not have any data in the table. This part of the tutorial, I'm going to introduce PostgreSQL database to you. To use PostgreSQL database, we have to download a tool called pgadmin4. pgadmin4 is an open source administration and management platform that is designed to work with PostgreSQL database. It provides a user-friendly graphical interface that allows users to interact with and manage their Postgres databases without needing to use complex command line tools. pgadmin4 works across all platforms, including Windows, Mac, and Linux. Now, to download pgadmin4, we're going to head over to Google, and in the search bar, we're going to type pgadmin download, and we're going to get to this page. If we click on this link, it's going to take us to the download page. We're going to scroll down, and you have to click which system you're using. So I'm on Windows. I'm going to click on the Windows icon, and it's going to give you a list of downloads. Now, me preferably, I like using the latest version. So I'm going to click on pgadmin4 v9.5. So I'm going to click on the latest version. So once you get to this page, you're going to see directories, files, and current maintainer. On the files, I'm going to click on the exe file. It's going to go ahead and download that file for us. So the file is being downloaded right now. Now that the file is done, we're going to open the file location. Here we have the file that we just downloaded. I'm going to double click on the download. It's going to bring this pop-up screen for me. Install for me only. I'm going to hit on next. Scroll down, accept the agreements, next. It's going to ask you for a file location. If you do not have any reason to change this path, I suggest that you leave it in the programs folder. I'm going to click on next, and install. When the download completed, we're going to go to start. Above, you will see pgadmin4 recently added. If you do not see pgadmin4, you can go to all, scroll down until you find it, or in the search bar, you can just type pgadmin4. We're going to click on pgadmin4. Once we click on pgadmin4, it will bring up this screen. Once pgadmin4 open up, you will get to this interface. We need to download a sample database so it can work inside of pgadmin4. We're going to download PostgreSQL sample database. So we're going to head over to Google, and we're going to type in PostgreSQL sample database. And the first link that shows up from Neon Postgres, that's what you're going to click on. And if we scroll down to the bottom, we will see the tables, the triggers, the views, the functions, and the domain and sequences that comes with the database. Now, this is the structure of the tables that we will be using in the sample database inside of Postgres. So to download the sample database, we're going to scroll down to the bottom, and it says download DVD rental sample database. So we're going to click on this link. This is going to be the database we will be working with. Now let's go back into Postgres and create a new server. So we need to connect to some type of server. in order for us to get access to the tables and tools inside of pgadmin 4. The next piece of tool that you need to work pgadmin 4 is PostgreSQL. Now, if you download pgadmin 4 and it does not come with PostgreSQL, you need to download PostgreSQL separately. So if I click on the down arrow, you will see that there is no servers connected to pgadmin 4. So let's head over to Google and download PostgreSQL. So once in Google, we're going to type in PostgreSQL download, and we're going to hit on download. Once you get on the download page, you choose your operating system. For me, I'm using Windows, so I'm going to click on Windows for the download. You will see download the installer. I'm going to click on that, and here I'm going to download the Postgres for my system. So I'm going to choose 17.5, and I'm going to click on download. Once download complete, we're going to go to the download folder, and we're going to click on PostgreSQL 17. We're going to click on next. If you do not have any good reason to change the path to the installation, I suggest that you leave it in the programs folder. We're going to click on next. It's going to say here what it's going to download. We're going to leave all of this checked. Then we're going to say next. It's going to ask us for a password. For that setup, you have to remember the password. So I'm going to put in my password, and I'm going to retype the password. You have to remember the password because it is going to ask you for the password when we go over to pgadmin 4 for the connection to the server. So I'm going to give it a password, and I'm going to hit next. And then this port is very important as well. So make sure you write down the port number for the server. And then I'm going to hit next. They're going to ask, select a local to be used by the database cluster. Okay, if you want to choose your zone, you can go ahead and choose it. But for me, I'm going to leave it as default, and I'm going to hit next, then install. Once download complete, we're going to click on finish, and then we're going to click on PostgreSQL 17 and hit next, next. We're going to click on next. It's going to bring this up again. We're going to click on next, next, next. And it's going to ask you to please provide the password and re-enter the password. Now, if you get to this step several times, you don't need to do it again. But what I usually do when I'm setting it up on different machines, I would just go ahead and hit cancel and say yes, cancel the process, and then say okay, finish. So now if we open up pgadmin, there is no server there. So let's go ahead and close pgadmin. Are you sure you want to quit application? Yes. And then we're going to reopen pgadmin 4. So now that we reopen pgadmin 4, you can see that one server available. So if we click on the down arrow, we can see we have PostgreSQL 17. Now it's going to ask you for the password that you just created when you were setting up PostgreSQL. So I'm going to enter my password. I'm going to click on save password and OK. Now, once I click on save password and OK, and we have the Postgres database available for us to use. Now, if we go down to schemas, and on the schemas, we're going to go on the public. And if we scroll down to tables, we have no tables currently in our database to do some work on. So let's go ahead and put the DVD database that we downloaded previously inside of the Postgres database. Now that we have all of the programs, software, and folders to complete the next part of the tutorial, let's go ahead and upload the DVD database that we downloaded from PostgreSQL. Now, if I go on the server, and on the server, you're going to see PostgreSQL 17. Maybe your PostgreSQL number will be different. Maybe you have 16 or 15 or 14. Currently, I'm running 17. On the databases, schemas, and then I go down to tables. We do not have any tables in our database. So let's go ahead and upload the DVD rental database we have downloaded from PostgreSQL. To do that, we're going to right click on databases, and on create, you're going to see database. So we're going to click on database. It's going to bring up this screen. You will have to name this database. I'm going to name my database DVD rental, and you can leave everything as is. It's currently on the Postgres. If you have this empty, just click on the down arrow and select Postgres. The OID, we're going to leave it empty. All of these other options, you can leave it as is, and then we're going to click on save. Now, when I click on save on the databases, you will see a DVD rental on the databases. Now, I'm going to right click on the DVD rental, and then I'm going to go down to restore. So I'm going to click on restore. And this is where we're going to add the DVD database file. So I'm going to come to my documents folder. I'm going to right click. Then I want to extract a file. And I'm still going to leave the name as DVD rental. And I'm going to click on extract. So if you open it up, you're going to see I have the extracted file. To add the DVD rental file to the database, I'm going to click on the file icon. Then I'm going to select DVD rental, and I'm going to say open. I'm going to select all files, DVD rental, and hit open. When I click on all files, I get a .tar file. If you get a .zip file, you will get an error. You have to make sure that the extension for the file name ends with .tar. You would have to extract the zip file to get a .tar file. We're going to come down to numbers of jobs. You're going to leave that empty. And for role name, we're going to click on Postgres. So scroll down to the bottom and select Postgres. We're going to click on restore. And in the bottom, it should say process start and process completed. If we click on schemas and we click on table, we have our tables in our database. These are the tables we will be using for the next part of the tutorial. If you're facing the process failed error when you are loading the DVD rental file into Postgres, here is how you can fix this error. Inside of the download folder where you have downloaded the DVD rental file, you're going to double click on that folder, and inside of that folder you will see another zipped DVD rental folder. We're going to right click, then press copy. We're going to go back into the downloads folder and create a new folder. So I'm going to name my folder DVD rental, and inside of the new folder that I just created, I'm going to paste the folder that I just copied from the downloaded folder. I'm going to go back, and you want to go to your C drive. Under this PC, you're going to see Windows, which is your C drive. I'm going to click on Windows. You have two program folders inside of your C drives. You have program files, and then you have another folder that is program files as well, but it has x86 beside it. You want to choose the one that says program files only. So I'm going to double click on this folder, and I'm going to scroll down until I see PostgreSQL. I'm going to double click on the folder, and then I'm going to see the number of Postgres that I currently have. So I'm running Postgres 17. You may have Postgres 16 or Postgres 15 or 14, but I'm using Postgres 17, so I am seeing 17. I'm going to double click on this folder, and then you would see the bin folder. Double click on the bin folder, and inside of this folder, you would see a bunch of files. So you want to select everything hitting Control A on Windows. If you're on a Mac, it's going to be Command A. And then you want to copy all of these files that is inside of this folder. I'm going to hit on the copy icon or Control C, and on a Mac is going to be Command C. I'm going to go back or hit the back button so I can be inside of Postgres 17. So if you look on top, I'm inside of the PostgreSQL folder, and then inside of the PostgreSQL folder, I'm in folder 17. Now you're going to go to pgadmin4 folder. So I'm going to double click on this folder. Then you're going to look for the runtime folder. So I'm going to double click on runtime. And inside of runtime, this is where you're going to paste the files that you just copied. So hit anywhere in here and click on paste. I'm not going to paste the files because my folder loaded properly into Postgres. But all you have to do is paste the file. A pop-up screen will come up saying the destination has files with the same names. You just need to select replace the file in the destination. Then a second screen is going to pop up. You're going to select do this for all current items, and then you press continue. Once you finish pasting your work, we're going to go back on the server. Then we're going to press on databases. We have the DVD rental database. We're going to right click, go down to restore. You're going to press the folder icon, and then you're going to choose the newly created folder. So if we go to downloads, this is the folder we just created. You wouldn't see anything inside of that folder. So what you want to do, you're going to come down where it says backup file dot backup. We're going to click on all files, and then you're going to see the DVD rental file. So you're going to click on this, press open. You should get a .tar file, and then click on restore. And this should fix the process failed error. When you open up pgadmin4, if you want to start writing commands, we're going to left click on DVD rental, and you're going to go down to query tools. We're going to click on query tools, and you're going to get the interface to write your queries. If we open up database, we have two different databases. We have the DVD rental database that we just created, and we have a Postgres database that comes with PostgreSQL. Now, if I go on the DVD rental database, underneath you would see a set of options. We're going to put our focus on schemas. So if I click on schemas, you would see a bunch of different objects on the schemas. So schema is essentially a namespace that holds database objects such as tables, views, procedures, functions, indexes, and more. You can create your own schema and put your database objects inside of that schemas. So remember, schemas hold database objects. To create a schema, you can use the keyword create schema and the name of your schema. So I'm going to name my schema sales. I'm going to highlight the query, and I'm going to click on execute. In the bottom it says create schema. I'm going to go on the objects and hit on refresh. Now if I close off public, you can see my new schema that I just created. A view is a virtual table based on the result of an SQL query. It doesn't store data itself, but displays data from one or more tables. We use views to simplify complex queries. We also use views to restrict access to specific data. When you're working on a database, you do not want to grant users direct access to the data. In SQL, you have two types of views. Single views, which derive data from one table, and it contains no functions or groups of data. A complex view, which derives data from many tables, and it contains functions or groups of data. On my screen, I have a complex query. This query is pulling data from multiple tables. So this is classified as a complex query. Now, if I run this query, this is the results I'm getting. So I'm adding the sum of 3 countries: United Kingdom, Canada, and the United States. Now take a look at the time in seconds it took to execute that query. When you're working with a big company that collects data, you may have to run a more complex query than this. So I can use this query and create a view. To create a view, the syntax will be create view and the name of the view. So I'm going to call this view CO_rev, which means country revenue. And I can say as. So when you're creating a view, you're going to say create view and the name of the view as. And then you're going to give your select statement. I'm going to select this query and execute. Now it says view created. Let's go down to the bottom where it has the views. I'm going to close off all of the tables. And now I'm going to go on the views. And on the views, you should see my new view that I just created called CO_rev. Now, if I look here, this is my view, CO_rev. So let's open it up and let's look at the column. We have 2 columns, country, and we did total revenue, which is the sum. And if we look under our view, country and total revenue. Now, if you want to use the view, instead of writing out this long query, we can say select star from and the name of the view. So the name of our view is CO_rev. So I'm going to highlight the select statement for my new view and I'm going to hit execute. And now you see that I got back the country and the total revenue. Now take a look at the time in seconds it took to execute that query. Index is another object you can find in a database. An index improves the speed of data retrieval on a table's column. An index in SQL works just like an index in a book. It helps the database find data faster without having to scan the entire table. An index can be unique, which prevents duplicates, or it can be non-unique. You can create indexes on columns that are often searched or used in joins. In the DVD rental database, we have the customer table, and inside of the customer table, we have a last name column. So if I do a select statement to display the last name column, and I will be grabbing this data from the customer table. And I'm going to order the results. So I'm going to say order by 1. Now, if I run the statement, the rows that came back was 599. And we can see the time it took this query to be executed. Now, 599 may not seem like a lot. However, if you're working with a company that collects data, for example, Instagram, TikTok, or any company that collects data from their customer or users, most likely will have millions of data. So sometimes you may be querying tables that hold millions of rows. Now, when you're querying a database that has millions of rows, the time it takes for that query to execute will be long. So the best way to reduce the time it takes for a query to complete is to put an index on a specific column or the column that you query quite often. So let's put an index on the last name column in the customer table. And to do that, we will use the syntax create index. And you have to give the index a name. So we're going to say last_name_IDX. And then we want to say on which table you want to put that index on. So we want to put that index on the customer table. And inside of brackets, we're going to say which column we want that index to be applied. So we want that index to go on the last name column in the customer table. Now let's highlight the query and we're going to run it. Now, if we look on the indexes, we currently have 2 indexes. Now let's refresh the database. And if we look now, we have our last_name_IDX. Now, if I go back and I run a query on the last name column, the time it takes for that query to execute will be a little bit shorter. So let's display some data from the last name column. So I'm going to say select star from customer where last name equals to Lance. Now let's highlight the query and hit on execute, and we will get back our information. Let's run back this query again so I can further explain how an index works. Now I ordered the results for last name. So because I have an index on the last name column, whenever we write a query that has to use the last name column, SQL will automatically use the index that is on this column to speed up the results. Now, with an index, this is what will happen when we query the last name column. We have 599 rows. So SQL will go down, we'll cut the row into half. So we will come down to 300 at least. So the index, it will not scan the whole database. Instead of searching up in the table, it will search down, because after K, it will be L. So right now, when the index search for Lance, the search will be much shorter. It will just go and look for L instead of scanning the entire database. TCL stands for Transaction Control Language. It is a subset of the SQL command used to manage interactions within a database, ensuring data integrity and data consistency. TCL commands are commit, which save all changes made during the transaction permanently. Then you have rollback. If something goes wrong, this command reverts everything back to the last stable state of the database. Then we have save point. Save point allow you to roll back to a point without losing anything. And the last one is set transaction. This lets you fine-tune how your transaction behaves, like setting the isolation level to avoid dirty reads and phantom rows. But before I show an example of each of the commands, let's take a look at transaction. What is a transaction on a database? So a transaction is a sequence of one or more SQL operations like inserting into a database, updating the database, deleting from the database, or running the select statement. When you perform a transaction, either all operations succeed and are committed, or none are applied and a rollback will occur. These type of operations ensure that the data is in a consistent state. ACID properties protects your data from corruption and unexpected failures of the database. Every transaction on a database follows the ACID principle, and there are 4 properties under the ACID principle. We have atomicity, consistency, isolation, and durability. Let's take a closer look at each properties with example. Let's start with atomicity. Atomicity ensures that a transaction is all or nothing. If any part of the transaction fails, the entire transaction is rolled back, leaving the database unchanged. This type of behavior prevents partial updates. For example, let's say we have 2 accounts, account with ID 1 and the account with ID 2. Now let's say we are moving $100 from ID 1 and we're going to put it in the account of ID 2. Let's say something is wrong with the account of ID 2. Maybe the account is closed or the account number is wrong. Then an error will occur. Once the system pick up an error, then the whole transaction will be void, having ID 1 not losing $100. Atomicity help to prevent these type of errors. Now let's take a look at consistency. Consistency guarantees that a transaction brings the database from one valid state to another. It ensures that all rules, constraints, and triggers are respected throughout the transaction. Let's take a look at an example of consistency. Let's say you created your accounts table and you have the primary key for ID and the balance, you have a constraint called check. Now, the check constraint makes sure that the balance in your account has to be greater than 0. So, account 1 with ID 1 is taking $100 from their account and putting it in the account of ID 2. Let's say the balance in account 1 is 0 or less than $100. Then the check constraint will kick in and then it will notice an error, which will bring back the account into a valid state. So it will not remove any money from account 1 because it doesn't have the amount of money in there to do the transaction. Then we have isolation. Isolation ensures that concurrent transactions do not interfere with each other. Each transaction is executed as if it was the only one running, preventing issues like dirty reads or lost update. Intermediate states of a transaction are invisible to others until it is committed. Let's take a look at isolation. Let's say, for example, me and my colleague, we're working on the MyShop database, but we're specifically working on the customer underscore backup table. Now, if my colleague run the SQL command, select star from underscore customer backup, we can currently see we have no data in that table. Now, if I come on my end, if I run begin transaction and I hit execute, now if I run back the select statement to see how many transaction count, it will currently tell me I have one transaction running. I'm going to copy the insert into statement and hit execute. If I come above and type select star from customer underscore backup and I run this command, on my end, I will get the data I just inserted into that table. Now, if my colleague run that statement, she will not get anything. So if we look at the bottom, it's trying to execute that statement. So that's an example of isolation. Now watch on the side where my colleague is working on. I'm going to run the commit statement. When I hit execute, now my colleague can get the result from the customer underscore backup table. And the last example is durability. Once a transaction is committed, its changes are permanent, even in the event of a system crash. This is typically achieved through login and backup mechanism. The commit statement is used to permanently save changes made during the current transaction to the database. If I run the select statement, it will tell me I have no transaction running. So let's start a transaction. I'm going to run the begin transaction statement. And now if I run back the select statement for add tran count, it will tell me I have one transaction going on the database. Now let's update the customer underscore backup table. First, let's run the select statement to see the data in the table. And we have customers from 1 to 4. Now let's insert a next set of values for customer 1005. So I'm going to hit execute. One row affected. Now let's run the select statement again for customer underscore backup. And now we can see that 1005 is in the database right now. Now, if anyone goes into the database other than myself and run a select statement for customer underscore backup, they will not see any data because I'm still using the database. I'm still in a transaction. Now, I have to save the changes that I made to the database. So in order for me to save the changes, I'm going to have to run the commit statement. And doing this on your database or doing this when you're working on a database is the safest way to keep data in a consistent state. So I'm going to run the commit statement. I'm going to bring the other screen to the side. And when I hit execute, then the person who ran the select statement for customer underscore backup on my left will now see the changes made to the database. So I'm going to hit execute, and now they can see the result of the customer underscore backup table. In order for you to use the commit statement, you have to begin a transaction. If I go ahead and I run the commit statement without a transaction going on, it will give me a message saying that commit transaction request has been corresponded, begin transaction. So you cannot run the commit statement without running the begin transaction statement. Save point sets a point within a transaction that you can roll back to without affecting the entire transaction. For example, let's begin a transaction. So I'm going to select the begin transaction statement and run it. And then I'm going to run the select add tran count. So we're currently in a transaction. So let's say customer 1004 called in and want to change the address. Let's run the select statement to see what is the current address for customer 1004. So the address is 91 Crowland Road. Now they want to change the address to 1929 Change Road. Let's run the update statement to make the changes. Now, if I run back the select statement to view the data in the customer underscore backup table, we can see that customer 1004, which is Mike, we just changed his address to 1929 Change Road. Then I'm going to save this transaction because this is a point in my database where there is no error and everything looks good. So I'm going to run the save transaction, and I'm going to give my transaction a name. So I'm going to call my transaction SP1. You can call your transaction whatever you want to call it. I'm going to call mine SP1, and it was completed successfully. Now let's say customer 1005 address needs to be changed as well. So let's run the select statement to view the data. And customer 1005 address is 91 Bruce Road. Now they want to change their address to 1929 Fixed Road. So we want to make that changes. So let's run the update statement for customer 1005. Now one row affected. I'm going to run the select statement to see the data. And I just noticed that customer 1005 address still remains 91 Bruce Road, but customer 1004 address has been changed to 1929 Fixed Road, which is the wrong address. So I just made a mistake in the database. Now I can go back to a point in my database where it was error free. So to do that, I can roll back the transaction to SP1 because SP1 stored a point in my database where there was no error and everything was safe. So I'm going to run the statement, roll back transaction to a specific save point. And that save point is SP1. So I'm going to go ahead and hit execute. And then I'm going to run the select statement again. And now we can see that the data for customer 1004 has went back to its original state. Now I can make the changes to customer 1005. So I'm going to run the update statement, and then I'm going to run the select statement. So we can see that customer 1005 has been changed and 1004 has been changed. Now let's pull up the second screen and run the select statement. And we can see that we still cannot get any data from that table, because when we roll back to a save point, we still need to make a commit. So let's go ahead and write the commit statement. When I hit on execute, then we should be able to get the data with the changes. So save point is a very good mechanism to use. And if you're writing long codes, it's always best to create save point and go back to a specific time when your database was error-free. For this part of the tutorial, I'm going to introduce MySQL on the command line. If you want to download MySQL, you're going to head over to Google and you're going to type in MySQL. On the first link that shows up, you can click directly to the downloads page. When you reach on the downloads page, you're going to scroll down until you see MySQL Community GPL Downloads. We're going to click on that. And then you want to click on MySQL Community Server. So we're going to select this option. And when you get to this page, we're going to leave it as and when you get to this page, we're going to leave the selected version as 9.4.0, which is the latest version. And then you're going to select your system. So if you're on Mac, you're going to select Mac. If you're on Windows, you select Microsoft Windows. For me, I'm on Windows, so I'm going to select Microsoft Windows. For the downloads, you're going to select Windows MSI Installer. And then it's going to ask if you want to log in. For this, you can just click no thanks, just start my download. Now we're going to wait until it's complete. When you're setting up MySQL server and you encounter this message, this means that your system requires a Visual Studio 2019 redistributable. So if you get this message, all you have to do is go over to Google and type in Visual Studio 2019 x64 distributable. This is going to give us all of the software and runtime that we need to run MySQL. So we're going to click on the second option, and then we're going to scroll down and download the latest redistributable. So the latest version is between 2015 and 2022. So we're going to select this option. So for this, I'm going to select the 64-bit version, because it is asking for the 2019 x64 redistributable. So I'm going to select the x64 version. Once it's done, I'm going to open up the folder it's in, double click on the installer. I'm going to click on agree and install. It's asking me if it's telling me I need to restart my computer before using the software. So I'm going to restart my computer. Now that I have resetted my computer, I'm going to open up the downloads folder and restart the installer for MySQL. I'm going to double click on the installer. Now we're not getting the message anymore. I'm going to click on next, accept terms and condition, click on next, and I'm going to do a complete install. Then I'm going to click on install. Now the installation is complete. I'm going to click on finish to complete the installation. Now, once the installation is completed, you're going to get to this screen. I'm going to click on next. If you do not have any valid reason to change the file path, I suggest you leave it as it is and click on next. Then it's going to ask you the configuration type. We're going to leave it as development computer. So everything on this page, you're going to leave it as is. Do not change the port because this is the default port, and also the protocol port. Leave it as is. Then I'm going to click on next. And here you will require a root password. So this is the information that you need to write down and save. Typically I would put my password as the same as the login for my computer. So create a password, and you can add a user if you want to, but however, I'm going to add a user on the command line. So we're going to leave it as is. Remember the password that you have typed in because you are going to need it later on. And then I'm going to click on next. It's asking if I want to start MySQL when the system starts. I'm going to leave this checked, and I'm going to leave standard system account. And then I'm going to click on next. We're going to leave this section as is because we want to allow the app to have full access to the runtime. So I'm going to click on next. And I want both of the database. These are just sample databases that comes with MySQL. So I'm going to select both sample databases and then I'm going to click on next. I'm going to click on execute and it's going to install all of these options for me. So I'm going to go ahead and click on execute to install. Once we get the message stating the configuration was successful, we can go ahead and click on next and then finish. So now that the installation complete, you can go to the Windows startup option, go to all apps, scroll down until you see MySQL. We're going to click on the down arrow option. And then we want to run the MySQL command line client. So I'm going to click on this option and it's going to ask us to enter the password. The password we're going to enter is the password we have used when we were setting up the installation. So I'm going to enter my password and hit enter. And now we have the MySQL command line to run on Windows. The first command we're going to run on MySQL command line is show databases. And show databases allow us to see all of the databases that is currently on the system. Now, when you write in a command in MySQL, you must end the command or the statement with a semicolon. The semicolon lets the system know that the statement is completed and do not look for anything further. If we do not add the semicolon, it's going to continuously prompt us to enter the semicolon or finish the statement. So I'm going to press enter without the semicolon, and then you will see an arrow popped up for us to enter the semicolon or continue the command. So I'm going to put the semicolon and then hit enter, and now it shows us all of the database that is currently on the system. Now remember, when we were installing the database, we installed two sample databases, Scala and World. However, you can create your own database. So let's go ahead and create a database in the system. So the command to create a database is just the same as SQL as what we saw in the previous video. So we're going to say create database my shop, just as how we had it previously, and then I'm going to use the semicolon and then I'm going to hit enter. So it says run row affected. Now if we go back and we run the show database command, we can see my shop is now in the database. So let's go ahead and use the my shop database. So to use the my shop database, all you have to say is use my shop semicolon enter, and it says now the database has been changed to my shop. You can also run MySQL inside the command prompt. So if we go to the search bar and we type in command prompt, you're going to click on this option that says command prompt, and once we inside of the command prompt, we can type in MySQL and hit enter. Now it does not run MySQL for us because we need to do a little bit of workaround. So right now it's saying MySQL is not recognized as an internal or external command. So let's go ahead and fix this problem. What we want to do, we're going to close the command prompt and then we're going to open File Explorer. On the File Explorer, you want to go to this PC, and then on this PC, we're going to click on Windows C drive. Inside of the Windows folder, we're going to look for program files. So we're going to double click and go inside of the program files. And then we're going to scroll down until we see the MySQL folder. So I have the MySQL folder here. We're going to double click to go inside of that folder. And then you would see MySQL Server 9.4. This number may be different for you. So I'm going to double click and go inside of that folder. And then you would see the bin folder. Okay, so we're going to double click on the bin folder. Inside of that bin folder, we're going to copy the path. So we're going to click on this part here, and then we're going to right click and copy paths. Now, once we finish that, we're going to go into the search bar and type system environment, and it's going to bring up this for us. So it's going to say edit the system environment variable in the control panel. So we're going to open this and we're going to click on environment variable. Once there, we're going to get to this part. Now this section here may be different for you guys. As long as you have the option that says path, you're going to click on path, and then you want to click on edit path, then go to new, click on new, and we're going to paste the path that we just copied from my SQL bin. So I'm going to press Ctrl V, and then we're going to click on OK, and we're going to click on OK for here as well, and we're going to click on OK. So now that we have all of this open, let's go back and reopen command prompt. So now we're going to type MySQL and hit enter. Okay, so that's good. Right now we have MySQL running, but it gives us error 1045, which means access denied for user. So what you want to do here, you want to log in as the root user. And to do that, we can just say mysql.exe -u-r-o-o-t, which means root. And then we're going to say -p, which is for password. We're going to enter. It's going to ask us to enter the password. So I'm going to put in my password and hit enter. And now we are using MySQL on the command prompt. To use MySQL on the command prompt, all you have to do is open up a new file explorer. Then you would want to go to this PC. Under this PC, you're going to go to the C drive. Then you have to look for program files. There are two program files. You have program files and program files x86. You want to click on the first program files. And here we're going to look for MySQL. So MySQL is right here. We're going to go inside of this folder, and you will see MySQL Server 9.4. Now this is the version I'm running. Your version may be different. Now I'm going to go inside of that folder, and I'm going to look for the bin folder. So the first folder for me is the bin folder. So I'm going to go inside of that folder. And then I'm going to come at the top to copy this path. So I'm going to click anywhere on this line. I'm going to right click and press copy. Now I'm going to open up command prompt. And inside of the command prompt, I'm going to say cd, and I'm going to paste the path. Ctrl V to paste, and I'm going to hit enter. Now I'm inside of the MySQL folder. So inside of this folder, I can run my command. So now I want to log in as the root user. So I'm going to say MySQL -u root. So root will be the username -p. And when I hit enter, it's going to ask me to enter the password. Now you have to enter the password that you have created when you were downloading MySQL. So I'm going to put in my password and hit enter. So now I'm inside of MySQL server. So the first thing, when you inside of MySQL, let us see the names or the list of users that are currently on the system. And to see a list of users on the system, you write select user from mysql.user. And I'm going to hit enter. And it tells me right now I have these 4 users on the system. Let's go ahead and create a user called Nikki. And the command to do that is create user. And I want to create the user Nikki. And then I'm going to say identified by, and I'm going to give a password for Nikki. So the password for Nikki will be pwd Nikki, and I'm going to give my semicolon, and then I'm going to hit enter. Now it's saying that query okay and 0 row affected. Create user and the name of the user. So in this case, the username is Nikki. And then you're going to say identified by, and you give a password. So when you use identified by, that means you have to provide a password for Nikki. Now let's run back the query again to see the users on the system now. And here you can see Nikki has just been added to the user profile. Now that we have created the user Nikki, let's go ahead and log in as Nikki. Right now we are logged in as root, so we need to exit out and log back in as Nikki instead of root. And to exit on the command prompt, we just type in the keyword exit and hit enter. And now we're going to log in as Nikki. So the command to do that will be mysql-u Nikki, which is the name of the user, -p. We're going to go ahead and hit enter. They're going to ask us for the password. The password is this password here. That's what we have created when we were creating the user Nikki. So I'm going to go ahead and enter this password right here. So I'm going to say pwd Nikki and enter. And now we have logged in as Nikki. So now we can go ahead and see which databases Nikki have access to. So the command to do that will be show databases. And I only have access to 2 databases on the system. If I type exit and go back and log in as root, and I write show databases, and here you can see the databases that I have access to. Now, if you want to drop a user, the syntax is pretty easy. Let's log in as a root user. So we're going to say mysql-u root-p, and we're going to enter our password. And let's take a look at the users again. So to see the users, we're going to say select users from mysql.user. On the users list, we have Nikki, mysql.infoschema, mysql.session, mysql.sys, and root. Let's drop the user Nikki. So to drop a user, the syntax is drop user Nikki. And it's going to say query okay, 0 row affected. Now let's run back the select statement again, and we can see that user Nikki is gone. So let's go back and create the user Nikki, because we will need that user in order to practice our grant and revokes. So the syntax is create user Nikki identified by, and I'm going to give the password, and the user Nikki is now created again. So if I go back and show the users, we will see that Nikki is now back in the system. Let's go ahead and create a user called Nikki. And the command to do that is create user. And I want to create the user Nikki. And then I'm going to say identified by, and I'm going to give a password for Nikki. So the password for Nikki will be pwd Nikki. And I'm going to give my semicolon, and then I'm going to hit enter. Now it's saying that query okay and 0 row affected. Create user and the name of the user. So in this case, the username is Nikki. And then you're going to say identified by, and you give a password. So when you use identified by, that means you have to provide a password for Nikki. Now let's run back the query again to see the users on the system now. And here you can see Nikki has just been added to the user profile. Now that we have created the user Nikki, let's go ahead and log in as Nikki. Right now we are logged in as root, so we need to exit out and log back in as Nikki instead of root. And to exit on the command prompt, we just type in the keyword exit and hit enter. And now we're going to log in as Nikki. So the command to do that will be mysql -u Nikki, which is the name of the user, -p. We're going to go ahead and hit enter. They're going to ask us for the password. The password is this password here. That's what we have created when we were creating the user Nikki. So I'm going to go ahead and enter this password right here. So I'm going to say pwd Nikki and enter. And now we have logged in as Nikki. So now we can go ahead and see which databases Nikki have access to. So the command to do that will be show databases. And I only have access to 2 databases on the system. If I type exit and go back and log in as root, and I write show databases, and here you can see the databases that I have access to. Okay. Now, if you want to drop a user, the syntax is pretty easy. Let's log in as a root user. So we're going to say mysql -u root -p, and we're going to enter our password. And let's take a look at the users again. So to see the users, we're going to say select users from mysql.user. On the users list, we have Nikki, mysql.info schema, mysql.session, mysql.sys, and root. Let's drop the user Nikki. So to drop a user, the syntax is drop user Nikki. And it's going to say query OK, 0 row affected. Now let's run back the select statement again, and we can see that user Nikki is gone. So let's go back and create the user Nikki, because we will need that user in order to practice our grant and revokes. So the syntax is create user Nikki identified by, and I'm going to give the password, and the user Nikki is now created again. So if I go back and show the users, we will see that Nikki is now back in the system. Now that we have created a user named Nikki, let's go ahead and log in as Nikki. And under Nikki's profile, we're going to create a database and populate the database with some tables. So to log in as Nikki, the command will be mysql -u Nikki -p. And I'm going to enter the password for Nikki. And now I'm logged in under Nikki. The first thing I'm going to do is create a database so I can add some tables to that database. So the command to do that will be create database. And I'm going to call my database my shop, and I'm going to hit enter. Now, if we look at the error we're getting, it's saying access denied for user Nikki. Now that means that Nikki does not have any permission to create on her profile. And to see that, we can use the command show grant, and I'm going to hit enter. We just have grant usage for Nikki. So that means Nikki does not have any permission to create, alter, select, update, delete, drop on her profile. So we have to go back and log in as root and grant Nikki some permissions on her profile. So we are going to exit from Nikki's profile, and then we're going to log in as root. So I'm going to say mysql -u root -p, and now we're in as root. Permission, or you may hear privileges, determines what a user can and cannot do on the system. As a DBA, you have the authority to grant new privileges to new users. The first grant I'm going to show is the grant all privileges. The grant all privileges is a very risky grant, and you do not want to grant all privileges to users or to new users. You will only grant all privileges to users that you trust on the system. Now, we have created the MyShop database. Let's grant all privileges on the MyShop database to Nikki. And the command to do that will be grant all privileges on, and I want to grant that privileges on the MyShop database, so I'm going to specify MyShop dot asterisk to Nikki. Now this is the command to give Nikki full access to the MyShop database. As I said previously, you do not want to give Nikki access to create multiple databases on the system. You as a DBA, you want to create the database and grant users permission to access the database. Now, when I run this statement, it says query OK. So that means Nikki have full access to the MyShop database. That way she can create table, alter table, update table, insert into the table, and so on. So let's go and log in as Nikki and see what we can do now with the MyShop database. Now I'm going to go ahead and log out as root. So the command will be exit. And I'm going to log back in as Nikki. So now we are in as Nikki. Let's go ahead and check the privileges again. So the command to do that would be show grants. And now you can see that Nikki have all privileges grant on her profile. Okay. So if I want to use the database, the command will be use MyShop. And now you see that the database changed. So currently I'm inside of the MyShop database. Now I can go ahead and create tables inside of the MyShop database. So to do that, I can say create table, and let's create a table called customer. And we're going to have a first name, and it's going to be a varchar with 20 characters. Let's create a last name. And this is also going to be a varchar with 20 characters. And we also want a customer ID. And it is going to be an int about up to 4 digits. And this is all for the customer table. So to create the table in MySQL is the same syntax as how we create it in Oracle, Postgres, and SQL Server. So let's go ahead and hit enter. Now we have our table created. Let's go ahead and type show tables. Oh, I spell show wrong. Let's rewrite it, show tables. And now we have the customer tables on the MyShop database. Now, this, as I said before, this is not the right way to grant access to a user on the system. So let's go back and revoke all privileges from MyShop database to Nikki, and we're only going to grant her specific privileges to the MyShop database. So we are going to log out as Nikki, and we're going to log back in as root. Now that we have logged back in as root, let's go ahead and remove all the privileges from Nikki on the MyShop database. To remove privileges or grants, you can use the revoke command. So we can say revoke all privileges, and then you have to specify on which database you want to remove the privileges from. And in our case, we want to remove it from the MyShop database .star, and we want to remove that from user Nikki. So the command to remove all privileges or delete all privileges from a specific user is revoke all privileges on the name of the database, from, and the name of the user. So let's go ahead and hit enter, and it says query OK and 0 row affected. So that means Nikki does not have any of the grants because we just revoke it. Now, when we say revoke all, this means that all was the privileges we gave to Nikki. So we're going to revoke all. Now, if we had grant create, then it will be revoke create. Okay. If we only granted alter, it will be revoke alter. Now, because we granted all privileges, we're just going to revoke all privileges. Now that we have revoked all privileges from Nikki, Nikki doesn't have any access to do any operations on the MyShop database. So if we exit out and then we log in as Nikki, and we say use MyShop. So you see here, Nikki doesn't have access to the MyShop database because we have revoked that access to Nikki. So let's go back and log in as root and give Nikki the proper access to the MyShop database. So I'm going to say exit, and we're going to log in as root. As a DBA, you only want to grant specific permissions to specific users. The proper way to grant specific permissions instead of using the grant all is grant, and you want to list the operations you want to grant to the specific user. So for Nikki, I want to grant create. I also want Nikki to have the alter statement. I want Nikki to also have the select statement. We're going to grant update as well, insert, delete, and drop. These are the only operations I want Nikki to have on the MyShop database. After, we have to specify which database we want Nikki to have this grant on. So I'm going to say on MyShop dot asterisk to Nikki. So I'm going to go ahead and hit enter, and it says here query OK. Now if we log out with exit and we log back in as Nikki, and if we go back and say use MyShop, now the database changed. Now I can go ahead and create tables. So if I go back and instead of using customer, let's say customer underscore backup table. So now we have access to the database, and I hit enter. It's going to say query affected. And if we say show tables, we're going to see we have the customer and the customer backup table. Now this is one way you can grant access to a database for a specific user. If I type in the show grant command, now I can see which grants I have on my system. So I have select, insert, update, delete, create, drop, alter on the MyShop database. Previously, we have granted Nikki a list of permissions using this syntax. However, this is not the proper way to grant roles to new users that are coming in on the system. Think about it this way. Let's say, for example, you're working for a large company, and that company hires about 15 to 20 people every so often. Whenever a new employee comes on the system, and let's say they're working on the MyShop database, you will have to grant these privileges individually to each employee. Keep in mind that the grant list or the list of privileges can't get much longer than this. There are much more operations someone can perform on a database or on a table. So the best way to grant privileges to users is to create a role. Now, what is a role? A role is just a list or a name of collections that can be granted to a user. So let's go ahead and create a role. To create a role, the syntax will be create role, and we're going to give the role a name. In this case, I'm going to name my role MyShop _ roles, and I'm going to hit enter, and it tells me that the query is okay. So now we have a role called MyShop in the database. So the next thing we want to do is grant a list of privileges on that specific role on the MyShop database. So the syntax to do that will be grant, and I want to grant create, alter, select, update, insert, delete, and drop on the MyShop database. And instead of granting it to Nikki, we are going to grant these privileges to the new role that we just created, which is MyShop _ roles. So I'm going to delete Nikki, and I'm going to say MyShop _ roles, and I'm going to hit enter. The query is okay. So now we can go ahead and grant the MyShop role to Nikki. And the syntax to do that will be grant, and instead of single quotes, I'm going to say MyShop _ roles, and to whom I want to grant that role, MyShop _ roles. So in that case, I want to grant that role to Nikki. So next time a new employee comes on the system and they will be working on the MyShop database, instead of writing out the long list of privileges, we're just going to write grant MyShop role to the new employee. So this is a much easier way to write out privileges and grant them to a specific user. So I'm going to go ahead and hit enter, and it says everything is okay. So now we have to set the role for Nikki. So anytime Nikki logs in on the system, the role is already there for her to use. So the syntax to do that will be set default role and the name of the role. And I'm going to say to Nikki. So I'm going to go ahead and hit enter, and it says everything is okay. Now let's exit and log in as Nikki. So I'm going to exit, and then I'm going to log in as Nikki. So MySQL -u Nikki -p, and I'm going to enter the password. So now we are in as Nikki. So I can now say show grants. And here I have select, insert, update, delete, create, alter to Nikki. And I also have the MyShop _ roles. Now that we have logged in as Nikki, let's go ahead and use the MyShop database. So I'm going to say use MyShop, and it says database changed. So now I can go ahead and create a table in the MyShop database. So I'm going to go ahead and create this table in the MyShop database under Nikki's profile. So I'm going to go ahead and hit enter, and it says query OK. We just created a table. So that's how you create roles and grant roles to specific users on the system. SQL is one of the easier programming language you can learn, but some parts might get just a bit complicated. You will come across complications when you are trying to move data around, also known as the ETL process. ETL stands for extract, transform, load. Extract meaning data is pulled from multiple sources, which can include databases, APIs, the internet, cloud storages, or flat files like a CSV file. Transform meaning the extracted data is cleaned, which means you are removing errors and duplicates. It's standardized meaning inconsistent format, and enrich, which means adding new data. Load means that the processed, cleaned data is moved into a target destination, typically a data warehouse or a data lake, making it available for users and application. In this part of the course, I will show you how to get data from the internet or whichever source, and then move the data from the internet file into a database. The first thing we're going to do is head over to Google and type in Ontario Top Baby Names 2019. When you get to the results, we're going to scroll down, and then you would see Ontario Top Baby Names, a data set. So the URL will be data.ontario.ca. Now, if we pay close attention to the information, they have been collecting data from 1917 to 2023. So we're going to go ahead and click this link. And if you want a related search for the female version, you can click on this part. And if you want the male version, you can scroll down and click on the male link. When you get to this page on the download data, there are different formats or file formats you can download from. So you have the CSV, TSV, JSON, and XML. So you choose whichever one you want to experiment with. But for this specific tutorial, we are going to work with the CSV file. So I'm going to go ahead and click this data set, and it's going to download for us. Now, once it's downloaded, I'm going to go ahead and open up where it has been downloaded, which is in my downloads folder, and I'm going to double click on the file. So this should open up in Excel for you. Now, when it has been opened up, we will see that the file itself has 3 different columns. We have year, name, frequency. So we are going to work with this file and experiment how ETL works. Now, we're going to take the data that we just downloaded from the internet and put it into a database. So we're going to go ahead and open up SQL Server Management Studio. And then the first thing we want to do is create a database. So let's go ahead and use the create a database command. And we're going to say create database and the name of the database. Now, I'm going to name my database male name DB. Male name DB. So this is the name of my database. So I'm going to go ahead and run the query, and everything is okay. So now I'm going to say use, and I'm going to copy the name of the database, which is male name DB, paste it, and then I'm going to run that query. So it's going to take us from master to male name DB. Now we're going to create a table to put the data in. But before we do that, when you transfer in raw data, it's always advised to use a staging table to clean and map and transform the data before moving it into a permanent table so it meets operational needs. So let's go ahead and create a staging table. A staging table is just as same as creating a permanent table. However, we are trying to clean the data before we put it into its permanent table. So we're going to use the word create table and the name of the table. I'm going to name this table male underscore name underscore staging underscore table. This is my name for this specific table. You don't have to name it the same. You can name your table whatever you want, but I'm going to name my table male_names_staging_table. And then we're going to need our open and closing brackets. Now, inside of the open and closing brackets, that's where we are going to list the columns. Now, let's go back to the Excel file. And in the Excel file, we have 3 columns. We have year, name, and frequency. So I'm going to open this a bit more so it's more readable. So these are the 3 columns we are going to put when we are creating the table. So let's come down here, and the first column we're going to put is year. So inside of the bracket, we're going to say year, open and closing, and the data type for year will be an integer. Then we're going to go down, and inside of the bracket, we're going to put name, and name is going to be a varchar, and it's going to hold about 50 characters. And the last one we're going to put is frequency. Frequency is going to be an integer. If I come back, let's open up the Excel file again, and I'm going to bring it down a bit so we can see we have the year, which is here, the name, which is the second column, and frequency, which is the third column. So let's go ahead and run the command. We're going to hit on execute, and we have created our table in the database. Now we have our tables created in the database. Let's go ahead and populate it with the data we have downloaded from the internet. To do that, we will need to use the bulk insert command to move the data. So let's go ahead, and in the bottom, I'm going to bring this down a little, and we're going to say bulk insert and the name of the table. So I'm going to go ahead and copy the name of the table and paste it. Now, after the bulk insert, we have to specify the location of the Excel file or the location of the data you want to move. To find that, we're going to open up Excel. We're going to go to File, and on the file, we're going to choose Open command. And here we will see Ontario Top Baby Names that we just opened. We're going to right click and then scroll down where you see Copy Path to Clipboard. We're going to click on this option, and it's going to copy the path for us. Now we're going to go back into Microsoft Server Management Studio, and in the bottom of the bulk insert, we're going to say from, and inside of single quotes, we're going to paste the path where the file is located. So I'm going to hit Control V. When we finish with this, I'm going to open this up a little bit more. We're going to come to the bottom, and we're going to use the keyword with. So we are trying to put some limitations on how we want our data to go into the staging table. We're going to put open and closing parentheses, and inside of open and closing parentheses, that's where we're going to put our limitations. So inside, we're going to say first row, and first row is just telling the system where to start. If we open up the Excel file, we do not want to start from the column. Okay, we want to start from the second row. You have to start where the data begins. Let's go ahead, and we're going to start from the second row. Then we're going to say format, and the format of our file is a CSV file. So I'm going to say CSV, and then I'm going to put a comma, row terminator. The row terminator will place each data record on its own line in the data file, or read the data file where one row end and another begin. So once I put row terminator, the first data will go in, then it will go to a new line. That's what \n mean in programming. It means a new line. So let's go ahead and put row terminator. And our row terminator for this one will be \n. Then the last thing we're going to do, we are going to put the last row. And last row going to equals to 10. Let's go ahead and put a comma right here. For last row, it's not necessary that you put 10. I just put 10 because I wanted to stop on Alan. However, you can put up to 20, 30. This data set contains a lot of data, up to 84,000 rows. So you don't want to insert all of that in the database. So for now, let's put the top 10 baby names in my database. Let's go ahead and run the query. And we got an error. Now this error is very important, and I purposely tried to create this error. Now, if you get this error, that means that it cannot load the data into the table because the file is open. So we have to go ahead and close the file. So let's go ahead and press close. We don't want to save it. So now that the file is closed, let's try to run the command again. And now we have our data in. Now that we have the data inside of the staging table, let's take a look at the data. So I'm going to say select star from, and I'm going to copy the name of the table and I'm going to paste it. I'm going to select the command and hit execute. And if we take a look here, we have our data that we just put in. So let me go ahead and open back up the Excel file to compare the data that we have in the table. So if we look here, the names start with Aaron because it started on line 2. So if we come here, we see first row, line 2. The format is a CSV file, which is this Excel file. And the row terminator is \n. \n means a new line. So when you meet the end of this column, go to a new line and input the new data from the Excel sheet. And then last row means we want to end it at row 10. So if we look here, row 10 is Alan. So right there, we know our data is good and our data is clean. Now the next step is to take the data from the staging table and now put it into the permanent table. Now what we're going to do is create another table. So I'm going to use the create table statement. So I'm going to say create table. The name of the table this time will be male underscore name underscore table. We're going to use our open and closing parentheses. And inside of the open and closing parentheses, we're still going to use the same exact column. So this is going to be our permanent table. Our permanent table is going to be exact same as the staging table, but we just created the staging table in case we have any type of discrepancy, because you do not want to put faulted data or inconsistent data into the permanent table. So I'm going to go ahead and run this query and everything is good. Now we're going to insert the data into the permanent table. So to do that is pretty simple. We're just going to say insert into males underscore name underscore table. So I'm going to copy the table name and I'm going to paste it. And I'm going to use the select statement. So I'm going to say select year, which is right here for us, name, and we also want frequency. And then we're going to tell the system where exactly we want to get this data from. So we're going to say from, and we want to pull this data from our staging table. Now let's go back up and copy the name of the staging table, and we're going to paste it here. Right now, this is the statement to do an insert from the staging table to the permanent table. So let's go ahead and run the query. The transformation went well. Now let's go ahead and do a select. So we're going to say select star from, and we're going to copy the name of our permanent table and paste it. So we're going to do a select star from males underscore name underscore table. Now this table here is the permanent table, and this table here is the staging table. So let's look at the data what's in the permanent table. We're going to hit execute, and here you can see we have the right data in the permanent table now. So that's how you do ETL in SQL.